Um, yep. Hello. Hi. Hello, everyone. Good morning, you bright people at 9 a.m. on a Friday. Um, so my name is Gustavo. I'm here to talk about a war story, something that I'm currently still doing at work. Um, so I work at a big financial company. I joined them about a year and a half ago, and I have to say that I've been really lucky. Not really lucky for the company because it's a company and a company's work, at the end of the day. But there's something that I've been really lucky with, and it's that within a big organization, with about 1,500 people in finance, which is quite big, I've landed on a team that is pretty much self-managed. The fact that we're self-managed means that we own pretty much everything except for our production machines. So we own the code, we own the builds, we own the deployment. Whenever we want to make a change, we just make a change in the code, put it into the CI environment, commit the code into Bitbucket now. It was a stash until about 2-3 weeks ago. And the Bamboo plan will actually build it for us and deploy it all over the place. So within this context, our hot potato shows up. So the first thing that I want to do is to define what is a hot potato, right? So a hot potato is a legacy project. It's a project that's been there in the company for about 10 years, and it's the sort of project where people will just put some functionality into just because it's easy to put it there. Let's say that you inherit a project which is 10 years old, and then you know that you're only going to work in that project for about 6 to 8 months, and then you're going to give it on to the next team, and you have something relatively hard to build. What are you going to do? A lot of people will just think, oh yeah, well, we need to re-engineer this because it's bad, because whatever. A lot of other people would just say, come on, let's do a quick fix. Let's just build what we have to build and chuck it into the next team. Um, there's no build plan for it at all. So all we have is we make a change in the code. We put that code we commit the code into Bitbucket, and then the build plan just builds it, puts the artifact into Nexus, and that's where we lose control of it. A QA will come, we'll take a look at the code, we'll run manual testing, integration test, all of that. And then if it's approved, then it will go on to the next stage. And if it's not approved, then it will come back to you. You fix the bugs and so on. So you carry on from there. And of course, it's critical to the company, right? Projects that have been there for 10 years. In this case, it's a communications project. It's a communications system. So all it does is it handles all the communications between the company and the client. So we work at a big financial company, which is basically you create an account with us, you put some money, you can start trading. So all the communications between our platform and the final user, like, oh, the market's going down, are sent and are received into this artifact, and then we send it to the client. So imagine how critical that is. Imagine the market's going down, which has been, I don't know if you remember, but at the beginning of the year or end of the last year, the market was very volatile because of the China thing. So imagine the amount of communications we send there, and imagine if at some point this went down and the clients will not receive that their shares were going down like really, really fast. Um, but this wouldn't be a problem if it worked, right? Because you say, oh, you talk to people and they say, yeah, but it's been there for 10 years. It's been working. It's just fine. It always happens that when things go wrong, they go wrong in the worst possible way, right? You imagine the worst possible scenario, and that's normally what happens. I always have this conversation with my girlfriend, and she says, why are you, sometimes she says, like, why all of this? I mean, it can go right, yeah, but it can go really wrong. And that's what we do, right? We're engineers. We should be prepared for the worst case scenario, because that's what's going to happen at the end of the day. So it happened that when we inherited this project, the volume of the messages, a new product was being put in place that will increment the volume of the messages like dramatically. So all of a sudden we got batches of 500 messages, and we got like thousands of these batches that we needed to dispatch. So that caused a lot of outages and everything. So it used to work, but it doesn't work anymore. Or it works, but we have to reset it pretty much like every week, which is really, really bad because cache will get overloaded and everything will be just like, at some point it wouldn't be working. At some point what happened was like the system was doing garbage collections constantly and will not send any more messages. So we actually had to reboot it like a weekly, and at some point it was almost daily. So you would think, come on, you're a big financial company, you are 1,500 employees, we are 680 people, we're 200 developers. Who lets a project like this get into this state, right? So we have this no blaming policy, so we're not looking for people to blame or to fire or anything like that, but one of these days I'll find the person, right? Anyway, moving swiftly on. What I'm going to do is I'm going to structure this in a certain way. I'm going to tell you what's wrong with it or some of the things that are wrong with it. I'm going to tell you how we convince management to actually put some money into a product that sort of works, and it's very critical, into refactoring all of it or rebuilding it. It's sort of between refactoring and rebuilding. I'll explain what we're using to do this. And also I'm going to explain how we are fixing this, what patterns are we using, what approach are we taking, because you know that for a critical product, you cannot really just go rewrite it, do the switch, and then hope for the best, because bugs are going to come up, and since it's very critical, you cannot just say, oh yeah, I'm just going to make the whole change and do the flip. That's not really how it works. So the first thing is, this project being so big and being so old, it's got many, many responsibilities. So one of the things it does is it manages the client preferences. It doesn't manage all of them, right? There's plenty of client preferences that you can have within the platform. But it manages how the client wants to receive the notifications. So let's say that I want to receive price alerts via SMS, and I want to receive major market movements via text, and I want to receive everything else via SMS. So all of these is stored in a database, but then when we start the system, we load everything up in cache, and we have about 150,000 clients. So we have 150,000 clients' preferences all in cache. That takes quite a bit of startup time. Then obviously it sends all the notifications, right? This is what it's meant to do. So this is not necessarily bad. It's not bad at all, but it's one of the main responsibilities. But then it also manages all the mobile device tokens. What does this mean? That means that when a user, let's say that you create an account and you create it with your laptop, yeah? So we store that you have a laptop and that you have an email account, yeah? The next day, you bring your phone out and then you log in into the platform with your phone, and that phone has a handle. So we store your handle in the system, and we know that you have that handle. So whenever a notification is going to go through SMS, through a push notification, we have that handle. But let's say that you have had an account with us for the past, 6 years, to give a number. You started trading with us in 2010. So on average, how many devices have you had since 2010? Let's say that a user changes the phone every 2 years, roughly, and you change your tablet every 4. So let's say that you have had at least 2 tablets and at least 3 phones. Yeah, that's 5 devices. How many of them do you use? You use 1 phone, 1 tablet, maybe 1 phone, 2 tablets, or maybe 2 phones, 1 tablet. That means that for every user, and I said that we have about 150,000 users, there's at least half of the devices that you're not using. There's a lot more because we actually run the numbers through that. So people mostly use 3 devices, and they have about an average of 8 devices that they ever use for trading, because sometimes you will use your partner's phone, or if you have kids, well, it's not a good idea to use your kid's phone, but probably some people will actually do that, or I don't know, they will just go into a different device and use it once or twice, and that's it. What's going to happen? All of these devices are going to receive these push notifications as well, as long as they have the platform installed. That means we are increasing dramatically the amount of messages that we're sending without any particular reason. So that's something we needed to cut down as well, because also it was sort of a security issue, because let's say that you receive it in a phone that you use twice and now you lend it to someone else to someone else, and that someone else is actually going to see what you're doing with your trading app, which for most of us, you'll have what, £100 or €100, and you made or lost €10, so it's not really a problem. But for a lot of users, that's a problem. And it's got a lot more responsibilities. I mean, there's plenty of things that this piece of code does just because it's been built incrementally. So we wanted to separate and maybe in little pieces what all of this was about. Another problem, that's a representation of what it looks like. So another problem is that the release cycle, right? I mentioned that our build was only that we committed the code into a repository, the Bamboo plan built it, and then the artifact was put into the repo. This is our old release cycle. In my team, we only use this for this project still. So I'm going to give you an idea of how it works. So let's say you want to make a change, right? This arrow represents the time in which you want to make the change. So after it's been released the last time, you make a change. It's a little bug that needs to go to production. It's not critical, but you need to fix it. So you make a little change. Let's say it's 2 lines of code, which is something very simple, right? And then you push the change into the repo, and then you have to wait for 1, 2, 3, 4 weeks, because our release cycle is 4 weeks for the test, and then someone in QA will actually grab and tag the snapshot and then do the QA. So after those 4 weeks, you get 1 and 2 weeks in which no changes are allowed unless it's some sort of critical bug. And then you will have 1 week to fix whatever problems are raised with your changes, right? So let's say you make a change here, and then you go through QA and they tell you, oh, there's a small bug here. If you have a small bug here, you have to go back here again, and then you will have to wait another 7 weeks to actually get any feedback on the new changes over the new changes you made, which is not ideal. I mean, you will test it yourself, right? But still, but still. So let's say it passes, yeah? And everyone's happy, and and QA signs it off. So the next week it will go into demo. It will stay in demo for about a week, and then if everything is okay, then it will go to production, yeah? So let's say there were absolutely no issues with your change. It took you 8 weeks to get a 2-line change into production. I went to a talk in London. I don't remember who he was. It was a workshop. It was not a talk. And one of the things, this guy was talking about continuous integration, and it was a brilliant talk. And he started his talk saying, the problem with our deploys nowadays is you don't think how long does it take you to make a 1-line change and put that into production. And that inspired me to think about this. It's taking us up to 8 weeks to make a 1-line code change and put it into production. That's absolutely ridiculous. That's not sustainable. Do you remember what you coded last week? Not this week, last week? Because I don't. I have to go back to the code and take a look. Do I remember what I did 8 weeks ago? If I go to the code I wrote 8 weeks ago, I will be like, who's the idiot that actually wrote that? It has happened. So we want to completely detach from this, right? As I said, we own our builds, we have our own thing. We want to move into that. So it's really flawed. So there are 3 things that I want to talk about why I consider it's really flawed. There are more, but these are like really, really critical. One thing is maintenance cost, then which are really, really high. Then there's no audit in sending the messages, which is pretty bad. Imagine you receive a message or you don't receive a message, depending on different cases, and the market is very volatile. That's pretty bad. And then there's a certain amount of downtime on deploy. I want to get into that a little bit more in detail. But before I go into that, so all the reasons that I've already given, for any of us developers, I guess most of us are just technical people, you would think, okay, yeah, that's good enough to put your hands into it. Let's make the changes, right? Is there anyone here that is not an IT person and actually it's a manager, of the sort of manager that decides, oh yeah, we're going to build that, we're not going to build that, and only look at the money, not at the technical aspect of it? No? Good, because you're not going to like this. This is how you convince management, yeah? You hit them where it hurts. You hit them with money. So this is a picture of my team as it was when we started this. It has changed a little bit. So we have an architect, one of these people. We have 3 senior developers. One of those is me. There was no one without her, so whatever. And this tiny guy here is a junior developer. So it has changed a little bit, but this is the people that started all of this. So let's say that a developer can work for about 1 or 2 points a day. Yeah, that makes between 5 and 10 points that you can do a week. This is an average. Some weeks you do more, some weeks you do less, and the estimates are never correct, but more or less. A dev costs the company £500 per day on average. Yeah, an architect will cost a little bit more, the team lead will cost a little bit more, the junior guy will cost a little bit less, but this is more or less an average. So £500 per day per developer. Yeah, that means that in a week you can deliver between 5 and 10 points, and it's going to cost the company about £2,500. Yeah, at some point we inherited this in November last year. At some point, we were 3 senior developers working on this full time for about, 3-4 months, and then it went down because we fixed a lot of bugs, but we still had a lot of maintenance. So I ran the numbers in March, which is when we stabilized the thing, and we spent, just as a roughly average, £135,000 worth of development only fixing this product, which is about between 280 and 480 points. So if you don't get, £135,000 sounds like a lot of money, but just to put it in perspective, if you're a startup, with that amount of money, you can hire 2 senior developers and an associate developer for a year. How much code or how many products can 2 senior developers and a middle-level developer create in 1 year for a startup? It's just ridiculous. It's ridiculous that it takes all of this amount of money just into fixing something. So we presented these numbers to senior management, right? So we have a very heavy process. We have to present a paper to a certain committee, and the committee has to approve it, and this committee only gathers every 3 months, and then some things will be approved and some others will not. We wrote it, we showed the numbers, and it was approved in a week. So that's record turnaround for the company. That was just incredible. They were just go and do it, because it's costing us way too much money. And we could be doing other things. We are doing all the big data. In my team, we're doing all the big data stuff as well. So we were not doing any big data. We were not delivering anything interesting for quite a while. So I'm going to run through all the other things. So no audit sent or messages. There are 2 scenarios. One is that you receive a message and the message is not true and we don't know about it. So let's say you get a message in your phone saying the market's going down, or so we're going to close your position if you don't put any more money because you cannot cover for it. And then the user panics and closes his position. Closes his position means that if he bought something, he sells it. Yeah, that's pretty much all it means. So the user closes his position and then goes to look at the market because he panicked. So you can go into the app in your phone and just sell it. There is a big button that says sell. And the user sold. And turns out that the market was going up. Since we don't have any audit, we don't know whether this client has received the message or not. So we rely on the client telling us, hey, I got this message. I sold because I believe that you're not gonna send me a bad message. And turns out that I'm wasting money. We are a financial company, as I said, and we're heavily regulated. That means that we have to economically compensate the client for the loss that he has had. And also, we'll probably overcompensate him because of the bad advertisement that we'll get out of it. Yeah. So this has happened. Yeah. And there is another possible scenario, which is the client doesn't receive a message and we don't know about it. As I said, with all the market volatility that we've been having at the beginning of the year and end of the last one, imagine if all these clients didn't know that China was down 5%. The Shanghai stock market closed at minus 5 point something percent one day. Imagine we never told them, and they lost 5%. There's clients, we manage all sort of people like us, or like me, I don't judge, which have just the right money to survive the month. And then there's people that got millions. Yeah. So these people For us, if we lose £10 more or £10 less or €10 more or less, it's not going to make me any poorer or any richer, right? But someone that's got millions invested, let's say that they lose 5%, 5% of a million, it's already a lot of money, it's £50,000. We would have to compensate these people because we didn't, terms and regulations say that we need to inform them, and anything that is in our terms and conditions we need to comply with. So we needed to put some audit into that. And actually it got to the point where we actually had to compensate some people because our messages were delayed by a few hours at some point because of the workload. So downtime on deploy. When we inherited this product, we inherited because my manager had worked in the team that maintained it before. So we were so lucky that when the team got disbanded, a team got all the people that were working on them and we got all their software. So we didn't get any extra hands, but we got a lot of things to do. It's a very interesting project we're working. I mean, it's something very interesting now to be able to refactor it. And actually, it's so good that I'm talking about it. But you can imagine that it was not brilliant. But anyway, we got it and we didn't have a lot of knowledge. So one day there was a critical bug in production and it was very easy to fix. So despite we have all of these huge pipeline to deploy, we can overrun it. If there is a critical bug, we can just accelerate all of this and do it on the go. So we needed to do this. So we overrun the process. We fixed the bug. We overrun the process. So we deploy into test. We deploy into UAT. Everything was working fine. We deploy into demo, and then it was working fine. And then we put it in production. So when I put it in production, I was sitting there and waiting for it to restart and monitoring the system and whatnot. And all of a sudden, I see a lot of people coming my way, and I was like, oh, I'm getting popular in the company. I had just started there. I've been there for about 3 months, and it's like, oh, these people are coming. I don't know, the three wise men bringing presents, whatever. But then I look at their faces, and I was just like, oh, no, and that they might not be bearing gifts. So they come to me, and they like, communication's down. And I was like, but yeah, I know, I'm restarting it. And we have like several servers. So, well, we actually have 2 servers. So you think you restart it, restarts one server, then restarts the other. That's not how it works. When you actually restart it, you put down all the machines, you reinstall the software, and then you bring it back up. You know the funny thing? It takes 40 minutes for every machine to restart. So we had an outage in production of communications for 40 minutes because there's so much workload. There's so much, the startup time is so long that everything goes down and you cannot actually control, oh yeah, I'm going to put one server down, I'm going to install the software, I'm going to bring it up, see if it works, and then I'm going to do it with the next one. I learned the lesson and I had to do it manually afterwards, server by server. The funny thing is that imagine if you have to roll back at some point, yeah? So you put something in production in one machine, you bring it up, wait 40 minutes, that's fine. It seems to work. You put it on the second machine, you bring it up, and then there's some sort of concurrency issue or communication issue between the machine. And then you have to roll back. You have to turn down one server, you have to reinstall, you have to bring it back up, bring down the second server, reinstall, bring it back up. That's 40 minutes time for plus some extra time to give it there. So you lost about 4 to 5 hours of work just because the downtime on deploy is so ridiculously high. So yeah, that makes us a very sad potato. So it's about time to redo it, yeah? So I'm gonna approach this bit into the 3 parts that we decided to take on. So the first one was to re-architecture all of it. I'm gonna show you later a picture of how our flows look like. Then we wanted to reach 0 downtime deploy, or as close to 0 as possible, because between 40 minutes and anything that is close to 0, there's already a huge difference, right? And then we want to detach from the old release cycle. The old release cycle is big, it's bad, and it's very, very ugly. So it's time to put our hands on into it, yeah? So the first thing we wanted to do is to re-architecture. I work with a guy here in this company that spoke on the first day, Daniel. He's not here. He must be still sleeping. and he said something really, really wise, and it's like, what do developers do when they gather all together to do some re-architecture? We draw squares, right? That's pretty much what we do. And he said this. He said, we don't get paid unless we draw at least 10 squares per day, right? So we sat together and we actually started drawing squares. This is a picture. I mean, you probably cannot say if the image was a bit bigger. You would see that behind the post-its, there are like literally squares that we drew. So we earn our payment that day. So what did we decide to do? So on our first meeting, we said, oh yeah, well, so we're sending SMSs, and then we're sending push notifications, and then we're sending emails, and then we're sending all of this stuff, right? Why don't we create like silly microservices that all they do is you put something into them, and then it just sends an SMS to a number, or it just sends a push notification to a number, or whatever. And we came up with all of these brilliant microservices, architecture, whatever. And then we had to do some work on something else, and then we sat again all together and went over the same problem again, trying to be a bit more precise about it. And then we came with another solution, and then the next time we sat, we came with another solution and another solution. So we decided that what we were going to do is to approach it incrementally. Instead of trying to re-architecture all at once, we were gonna slowly make the code a bit better and see where that takes us rather than doing this. And that's an approach that Martin Fowler actually had a brilliant idea, and I will come to that a little bit when we move in the next couple of slides. So this is a picture of a workflow that I worked in. Right? There's a lot of decision making. I don't want to get into all the details in here because that's well, you really don't need to know, and it would be like a bit boring. But mostly what we do is we get a message here, yeah, which is a generic message. We figure out what sort of message it is, and once we know what message it is, then we go through all the enrichers to actually send an email, well, an internal email through the platform, or any of the push notifications. So we have Google, we support Apple, we support Microsoft. At some point we supported BlackBerry. Which if you think is stupid, well, sometimes it is. But the other day we got a complaint. This is a little story. We got a complaint from one of the finance team, well, the traders, because we have a trading flow. And he said, oh yeah, a client actually told us that he had received an SMS on his phone, and but he didn't see the transaction happening, so he wanted us to check us. And it was like, oh, can you please send us the whole thing so we can actually look at it at the logs? And they sent us a picture that the user had taken with a Nokia 3310 that had a text, and he had taken a picture with his smartphone, and the guy was actually trading on a 3310. So yeah, we sort of support Microsoft, but on a ridiculous level, right? Fortunately, BlackBerry has announced that they're not making any more phones anymore, so that's good. One less thing to support. So yeah, this is the idea, right? So you can say, come on, let's just check it out, rewrite the whole thing, because it looks really bad, it's really hard. So we use a Spring integration as well, which at some point might have been a good idea, but the one thing that I don't like about Spring integration is that it's really hard to track. So when you're debugging, it just jumps from internal classes into your own classes, and it makes it really, really, really hard. So it took me like 2 or 3 hours to actually write that down with pen and paper. That's why I wanted to show it, because yeah, it took some effort. We're still using Spring integration, but we're using it a bit less, so the balance is a lot better from my point of view. So our approach for refurbishment is what Martin Fowler calls the strangle vine pattern. It's amazing what you can do with a bit of paint, right? The strangle vine pattern, I don't know if you ever heard about it. So Martin Fowler says that when he was in New Zealand, traveling around, he went to see these strangle vines, which is just vines that hang from trees. So what these vines do is they wrap around the tree, they strangle the tree, and they thrive in the meantime. So at some point you end up with a rotten core that is dead and completely useless, and all of these really, really nice vines that have entangled around it. So the idea is, let's just try to, one by one, extract all these flows, break them from a certain point, which is more or less here, and rewrite that bit. Yeah? Fortunately enough, we were very lucky. And while we were talking about this, someone came and said, oh, we need these new flows added because we're going to send a new sort of notification to people. So we used these as our starting point. So these new flows, we took them, we put them in place into the decision making. So as I said, we get a generic message, and then at this point, this is where we say, oh yeah, this is the sort of message that we're doing. And at this point, we started our new code. So we basically created a new model, and this new model was the first strangle vine that we were going to use. This flow here, it's one of the old flows. So already, this is the decision making, and what we do is instead of checking the message and bringing the user preferences and all the user statistics and all the mobile handles for the user, what we do is we create all the messages no matter what. I mean, instead of making the decision, we put in memory, we create objects for all the types of messages, which is just 4 or 5 different, right? It's an SMS, it's an email, it's a couple of push notifications and whatever. And then from the user, we just filter out the ones that are not. We thought that was a better approach than having to make decision all the time. So we got these objects that we just send into a queue right away, one after the other. It might sound like a bit of an overkill, but if you think about it, all the decision making, and actually we run the numbers, all the decision making will actually take a lot longer to create everything. And at the end of the day, if we have to go to the cache every time to get every handle and go through the flow, it's a lot more costly in time and resources than actually doing that. So this was our approach to Rearchitecture. We've migrated about half of the flow. Most of them are the hardest ones because our architect decided that instead of going for the easy one first, let's just go for the hardest one. And from there on, it should be really straightforward. And it actually was a brilliant idea. I was a bit against it at the beginning, but I have to say that he was quite right about it. So that's for rearchitecturing. We wanted to reach 0 downtime on deploy. So we had 2 approaches, yeah? Or there are 2 basic approaches. The first one is canary release, and the second one is blue-green deployment. For those of you that are not really familiar, canary release means that you deploy into a server and then check that that server is working. You put a number of users into it. If it works fine, then you start deploying into other servers and so on until all your servers have been migrated. Blue-green deployment means that you have 2 different sets of servers. One is in production and the other one is one is live and the other one is dark. And then when you want to deploy something, you deploy into dark, you check that everything is working, and then you do the flip. You put the dark in production, and the one that was live now goes into dark. And then when you want to deploy, you do the same thing again and again. This is still going on, and this is an argument that we're still having. We only have 2 servers, right? We have asked for more servers, and they have said yes, of course, but big company, buying new machines, everything takes ages, right? We, instead of buying small servers, we buy these beefy machines that cost about £100,000, and you can have like 20 different Tomcats running on them with 20 different things. But then again, when we need to buy a new one, we're already so late that we need to allocate all the things that were there. So this is an ongoing thing. So we've actually reached some sort of agreement, as in we're doing canary release at the moment. We've checked the code, or we changed the code enough, so now that instead of taking 40 minutes, our average is 58 point something seconds, yeah? So that's quite a change. And it was mostly because every time we went to load the cache at the beginning, we went to the database, we brought the results for one user, we wrote into the cache, and then we went again to the database, right? So that takes, for 150,000 users, you have to make 150,000 calls to the database, which was not very efficient because the database was doing other stuff in the meantime, right? So what we do at the moment is we deploy into one server, we wait for a minute for it to heat up, and then we deploy into the next server, which is not technically canary release because we don't really test it before we deploy into the second server, but it sort of works just fine because we have the demo environment, which is exactly the same. So every 6 months, we flip the demo environment with the production environment, so they have to stay in a very stable way. If at some point the flip goes wrong, then they're going to wake you up at 3 a.m. in the morning because they do this deployment on Friday at 3 a.m. in the morning. So you really don't want that to happen. And the way we are going to approach it when we get the new machines is going to be blue-green. We're going to have a blue server, and then we're gonna have a live and dark, and then we're gonna deploy into dark, and then just turn it around to reach zero downtime on deploy. So as I said, we've already optimized the startup quite a bit. It was mostly because of the cache thing. There were other things that were optimized a little bit, but that was the major stuff. And as I said as well, make sure that one server starts before deploying into the other. So we do this little canary once the server is up and we see the logs. We see in the logs that the things that need to restart are there. Then we see that we can restart the other. Otherwise, we just fail and we roll back immediately. And then to detach from the old release cycle, I built the full bamboo plan like on the first day, right? It was like, oh yeah, we're going to refurbish all of this. I'm going to build a bamboo plan. And then I realized we only had 2 machines. And then I was like, oh, but if I deploy into here and it takes so long, then I cannot use it. So the bamboo plan is there. It's written. It took me like a couple of hours to write. And all it does now is when you commit the code, it builds it, it puts the artifact into Nexus, and then it deploys into test, and that's pretty much what it does. But the good thing is already there. So when we get the new machines, we'll just have to reactivate all the other steps, and we'll be able to deploy immediately. So we get out of what we have here. So as I mentioned, this is still work in progress. We've migrated a bunch of flows. These flows we're about halfway through. They are a lot more efficient. They are a lot easier to read, which is when I write code, that's my main goal. I mean, if the person that comes behind me has to be able to read what I did. When I find code that, well, the variables are called I, A, and C, it really annoys me because then I have to figure out what all of this does. So the names of the methods are about this long, but you don't really need to read the code at all. So you just read the method, and then you just read what it calls, and then you just carry on from there. As I said, we're still waiting for the servers, and finally we're seeing the first bug in production. So that means, to me, an application is mature when you start seeing bugs. So you can go into, I don't know if any of you have ever worked in a product that you've never seen a bug in. It never happened to me. There's always a little thing, there's always a case that hasn't been thought of, or you cannot test all the positive and all the negative scenarios and so on. So when you really start seeing that an application is lacking stuff is when you put it in production and people do things that you never imagined that could be done. So we're seeing the first bug in production, which are not critical, which is brilliant. That's why I say yeah, despite we see the bugs. It's things that are very easy to fix and are not don't have any real impact on a platform, and that's brilliant. And yeah, there's just one more thing that I want to say. You've been really patient with me, and none of you have seemed to fall asleep, which is brilliant. So this is the last slide, and I just want to leave you with a few things. The first thing is, it was really, really good to have business on your side, on our side. It really helps when you're actually having, so we have a new product owner. We have had 2 or 3 product owners in the last 9 months, 10 months or so. And the fact that we had business on our side actually made the case by itself with the product owner, like, yeah, we're going to deliver some new stuff, but this has been approved, so we're going to work on this, because it's not you that gets waken up at 3 a.m. in the morning if something goes wrong, it's us. So we're going to work on this because, 1, it's good for the company. 2, we really like our sleep. I have a cat. We just adopted a cat, and the cat wakes us up at 5 a.m. So being waken up at 3 and at 5 is really not a thing. And then business says that we can do it, or we have to do it. So the argument is done by itself. I mean, a product owner is very chill, but sometimes he gets a bit like, oh, but there's people asking me to deliver stuff. Anyway, deal with your own stuff. It says stuff here. So if you inherit a project or you create a project, even if it's bad, I mean, when you inherit it, if it's bad, don't just think, oh, I'm going to do this, and then since it's going to go to another person, I'm just going to do it quickly, do it dirty, and then just go away, look the other way. Because when you inherit it, you're really annoyed by what sort of things people have done there. So something, a guy that I used to work with, and now I'm working with again, but he's in another team. I consider him my mentor. He said that when he works on a piece of code, he never leaves it worse than what it took him. So at least he tries to do something either as bad or a bit better, because anything that you can enhance or improve over something that's bad, it's already a win. We are using an incremental approach. As I said, when we got the approval, we tried to do the whole thing at once. Yeah, like, oh yeah, let's create the bamboo plan. So the bamboo plan is sitting there doing nothing. Let's just create all these new microservices. Let's just do. So that was completely unrealistic. So the strangle vine pattern was a really good approach. We read about it randomly somewhere after we had started, and then it was like, oh, this is exactly what we're doing. It's a brilliant idea. So we read a little bit more about it, and it actually made a lot of sense. And the last thing I want to say is that be proud of what you do. I mean, it doesn't matter if you've been working on something for a couple of months. Well, it doesn't matter. Business will care about it, but they don't need to know. If you've been working on something in a couple of months and you realize it's not the right way, just don't be afraid to try and say, look, we need to check this out of the door and we need to start all over again, or we need to revisit a lot of the things that we have done. At the end of the day, most of us are on this because we like it, because we enjoy it, and I want to be proud of what I do. So with that last thought, I want to thank you for coming, and if you have any questions or anything, just please ask. Yep. Yeah, I need that.
So you got rid of all the Q&A steps, which is probably a good thing, but you did tell me that you did put in automated testing.
Yes, we do. Well, we had some automated testing in place, but something we do is for every flow that we have, we actually have an integration. We have an end-to-end test for the flow, and then what we try to have is write more integration tests that when we deploy in the platform, we run that integration test in UAT, and then we run them. We try to run them locally, but then locally it's normally mocks that we test against. So when we don't really rely on those too much, we don't rely on integration test until we actually put it into UAT. But we've written a lot of new tests for the platform, which they were not there, not in place. Anyone else? No? Okay, well, coffee time, I guess. Thank you, guys.
technical guys are holding us up, but it's okay. Okay. So thanks for coming to our presentation. This is a presentation of Saga. My name is Nebojša Bjelatomić. I'm a CEO of Saga. And the very difficult moment for me was when they told me that I'm going to speak to this presentation, because our original thought was that we were going to send one of the engineers who's going to talk about some of great projects that we do, and they will talk to you guys and talk your language. And then they tell me, no, there is a business track, and it's up to you to have the presentation. And then since then, for several weeks, I was, breaking my head of what should I talk to you and actually make it worth your time to come in and hear our presentation. So in general, we want to tell you a bit about experiences that we had in last decade or so, and things that I think can relate to you and some of your interests. Probably if you know about Saga, you have the question, why is this dinosaur system integrator talking to the development conference? What the hell are these guys doing? Is this just a marketing trick? What are they doing? There is no customers. Are they trying to recruit? What's the point? Well, the truth is we are a 30-year-old company, and since we have these decades behind us, maybe we don't fit so much with all other companies that are barely 10 years old or several months old. But we have the same experience that most of you guys who are trying to start up or who are working in small companies have, except that we keep going this over and over and over and over, because as we all are witnesses in IT, things change very fast, and 3 to 5 years is an entire era. So I would say that in 30 years we had at least 6 or 7 cycles. So presentation today is supposed to cover 3 topics that I thought might be interesting for you and that are very, very hot with our company as well. First one is we have knowledge. We know something. We know it really well. Is it a programming language, procedures, or just some specific knowledge about industry? Well, from knowledge to a product is a really, really, really long way. And it's a lot of pitfalls and chances that you meet along this way. And there is not a right path. There is many different paths, and I was thinking about sharing some of our experiences and how this process happens in our company. Another topic that I wanted to share with you is financing. So as you might know, Saga was sold to investment fund some now 8-9 years ago, and since then Saga itself went through a lot of changes, and we learned a lot about what the investor wants and how they operate and what these funds are all about. I can add on the other side my personal experience, because I studied in States in Boston University. So, and originally I was an engineer in biotech. So I finished biomedical engineering, and at that time it was all about DNA and map of genes. And actually my thesis at the time was annealing of DNA for DNA chips. And then I started working at a startup company that was dealing with protein chips, and it was at the time in the first round of financing, and I was with this company until the second round of financing. Then I figured out I don't like living in the United States, and I came back and I became a salesperson and then later on manager. So I gave up on my engineering. But from there on, let's say in the last 20 years that I've been around the block, I went through different phases of the companies, and all along I met the financing people and hear from them what they expect from technical or engineering companies. So that's another topic that I want to cover with you. And then founder's dilemma. Let's say that we look fast forward through all the problems of creating the product, making a company, financing it, and then you come to the point of, do I sell or do I don't sell? And actually it's a quite interesting story, and there's a lot of papers about this topic. But if you come from Saga, there is a really a good story from the first person about our founders and the fund that bought us and what was going on in the last 4 or 5 years. And I was about to share some of these goodies of inside story. So back to, let's say, a first subject. So in my daily dealings with engineers, you always find this problem of we know and they don't know. Typical engineer will tell you that engineer can do everything, but no other people can be engineers. And there you have a first barrier. And then you start talking to them about, okay, so what we're going to do with your knowledge, how we are going to commercialize it, how I'm going to pay you a salary. You start that, and then I build another barrier because I start talking about money. And engineers it's not about money, it's about ideas, and it's about exchanging the ideas and growing and building great things. And then we go into philosophy. But at the bottom, you have to build something and you have to sell something. And what I'm going to try to do, at least in my first part of this presentation, is try to convince you that selling is not bad. Word sales in many cultures have a very negative connotation. Actually, when my father gets really, really angry with me, he tells me I'm a salesperson. That's it. That's how he draws the red line. And after that, I don't talk to him because I know he's way too pissed to continue conversation. And he underneath that is that all these applications, you've been engineer, you should have been a PhD, and you should have been working in a lab doing something cool. Instead, you're selling things to people. Where when you talk to other engineers, selling and cheating, that's somehow it's there. It's not completely a separate things. And that's not true. I mean, you can everything you do, you can do it in a bad way. So selling is a good thing. You need sales. You need sales. Doesn't matter what you do, you need sales. And that's going to be my mantra for at least first 15 minutes of this talk. So that's what I say. We know, and then somehow we go along the line and they buy. And that's very important. And in my opinion, whatever you build, it's not about do you like it or do you feel good about it. It's an important part of the whole process. But in the end, somebody wants to separate themselves from some value and to give it to you for the product or service or game or whatever you made. And I do believe that in the thought process of what I'm going to do and how I'm going to approach this whole idea of building something, either a product, a piece of code or a company, you should think about people that you are going to approach to exchange value for what are you building. And I think that this helps the whole process of making your task or making your efforts more successful. And in the end, I don't buy the thing that you're doing it just for sake of doing it. We all want to be successful. We want to be recognized. We want other people to at least like, if not adore, what we do. So if you think about these people who are at the end of the process, at the beginning of your thought process, you help yourself, and in the end, you are more successful. So in reality, we know they buy is not a straight line. It's a really curvy road of how you get there, and it doesn't matter how long you are in industry, and it doesn't matter how many successful projects you had in the past. When you sit down with engineers, it's a curvy road of getting from their knowledge to making something countable. So lately, we are talking about big data, then you go into BI, then you go into machine learning, data learning, and then you get these guys, and usually these guys are database guys who are very good at handling a lot of information, but throughout the history in three-layer, these are the middle guys, so not the guys who are in front. And most of the time, these guys, today's BI guys, are yesterday database guys, and they are not used to seeing customer, or they're not used to talking about customer. And my favorite line is that when I talk to my BI, which in Saga we have, and I tell them, okay, what we are going to build and what we are going to sell to the customers, they tell me, bring somebody to tell us what they want, and we will make it. Trust me, we can do it. And I'm just like, wait, that's not how it works. If they know what they want, they will go to their friends, cousins, previous partners. They will not come to us. They are coming to us because they're not sure what they want. They look at the internet, they read, and they say, okay, big data, Internet of Things. You have a lot of data. You can monetize this data, but they know how to do it. So you need to help them, do this. So then we go to first presentation. I made a huge mistake. I didn't look at the presentation of our engineer. It starts with algorithm, another algorithm, another algorithm. We're in the bank. We're talking to the head of their retail. The guy is like like, you know, I don't know if you ever looked how the in the gasoline station the pump measures. See, there is like a thing that turns around, and this guy is like turning faster and faster. And I thought the guy is going to like have an epileptic attack or something like that, and my guy is going, and he's like, you know, he's at his best in his head, you know. And at some point I say, can you skip this? And then, you know, we have argument right in front of a customer. He's like, no, but I want to show them that I know, so that they trust me that I do this for them. And I'm saying, what to do for them? They will tell me, you know. And the guy looks at him and says, to tell you what? And then we hear the great story, because it's one of the banks here in Serbia, and they tell us, listen, every salary that comes to our account is something that, you know, it's enough for paying the basic bills. So I don't need the BI to tell me what my customer are going to do with their money. You know, I mean, do you have something more interesting for me that I can, you know, speed up my processes or acquire more customers or whatever? I don't need you to analyze my data, because I know you're not going to get what I want from my data. And my guy was like, problem. And then we, you know, try to save the face and exit there without, you know, too much negative publicity coming out of that meeting, you know. And then we sit together and we start thinking about, you know, what to do and how to do, and you know, how to make the whole process work of, you know, we know and they buy. And then we say, okay, let's think, you know, how to get to their level, you know. You know, these guys are smart. I mean, when I say these guys, the guys with the money, the guys who want to exchange value with you. So they will read something, they will look into something, they will look into data, especially if you put it to their level. So, you know, you can make a case. You know, you write something about what can be done with your knowledge. But you have to talk about his business. You don't talk about your knowledge, you talk about his business. Then you can do proof of concept, which, you know, everybody likes. You know, generally, you know, IT guys like to see new things. You approach the let's say core business, and you agree that you're going to do a proof of concept. So, you know, it's a difficult, you know. Again, typical engineer comes and says, wait, but we cannot make a whole project just to prove it's going to work. You know, you have to somehow make a small sample piece, something effective that can be shown as a concept. That's a word, you know. It's not a whole project, it's a concept. And then if you pass that, then you can go into a pilot where you already can maybe even talk about some money and exchange, you know, a value with your customer, because through proof of concept you bought their interest, and in the pilot phase you can maybe blow a bit of your development people and really engage them into developing of at least the first parts of the project or separate parts of the project. So what I'm trying to say is that there is no straight line from we know they buy. You have to somehow devise the steps. These are general steps, maybe even too academic, but you cannot expect somebody to recognize your greatness. You have to convince them that this is what they need, and you have to get down to the let's say emotional level of what they need. So in general, another thing to consider is that we all want to make a product. We all dream about something that is completely packaged to the level of marketing agency coming in and you know, marketing it to the people as a great thing that they want to buy. Another thing that you can consider is that you can sell mandates, meaning that, you know, once you prove yourself as a knowledgeable person or a knowledgeable group of guys, you know, you can go there and, you know, try to be consultants. Okay, now I know I'm reaching, you know, you are 20 something, or you know, self-employed, and you go to some big industry and knock on the door of, I don't know, insurance company saying, you know, hire me as a consultant. And it's how do you believe in that story by yourself? And then we go back to this, you know, proving yourself, making a pilot project, having a case. Actually, believe it or not, if you go into the financing and whole conversation about money, you know, these guys actually would like to hire as a mandates rather than buying a pilot, because, you know, once they have you as a mandates, you are what they call OPEX, one-time cost, that they know exactly how much they pay you and you know what they're going to get out of it. And that what they get out of it is not very difficult for accounting. You know, if they buy your product, they go into this whole mess of about, you know, how they put it in their books, how they do depreciation, and it's complicated for them, trust me. So, you know, having a mandates purchase from you is actually not such a difficult proposition. It's just you have to have audacity to believe in yourself that you can sell these mandates, this, let's say, consultative work. And if you know something specific and you are sure of yourself, it will fly. And this is what is beautiful about what we do here and why engineers are and generally IT is great. IT in last quarter of the century really went into every pore of society or economics, but people are still afraid of it a bit. It's in my opinion, it's like the same thing as electricity. Everybody is using it, but it's something that can kill you. So in many ways, these financing people or at least non-engineering people consider IT the same thing. It helps you, but it can kill you because it can crash, it can lose your data, it can stop your business. So in that sense, you show in front of them and you're knowledgeable, you can sell yourself, and that's a good proposition. It's a good start. So don't be afraid to try to be consultant and through that way get into the customer before you try to sell them a product. So if I didn't iterate enough that selling is not bad, let me try it with this slide. So selling is not dark art. Selling is not bad. Selling is not peddling something that people don't want. It's just you communicate about your knowledge, your experiences, something that you know and that assumably other people don't know or they need. So if you are starting a company or you have a group of guys who are thinking of going into that direction, it's good to have somebody who you are going to consider as your go-to guy to go to the market, because you cannot be aliens in a sense of we have this great story and then somebody will come and recognize it. You have to think from very early goings of how you get to the market, who is going to talk in front of you. And as everything in Latin, there is this repetitio mater studiorum est, repetition is the mother of study. So the more you do something, the better you are at it. And they're natural salespeople, they're natural people who can go and talk to other people and sell them. But in general, this is also something that you keep going through the process, and over time you feel more comfortable in the process. And that's why I say if you have a group of guys going into something in sense of development or building, let's have someone who is going to be the guy who does that over and over and over, and hopefully by the time you're ready to actually engage into talk about financing, market, sales, you have one guy who is talking that language. And I think that's a good approach. So I honestly do believe that engineers can sell to other people, not to themselves, and they have to really, really try. They want to try. It's not something that just happens. It needs, let's say, you need to be willing to do that and to engage with this. So your knowledge is important, no doubt about it. I hope that I didn't, at any point say that knowledge is not important. It's very important and it's key. Without it, you cannot go anywhere. But the key is what customer needs. And you have to think about customer needs, not just about your knowledge. And that is very, very, very important. I cannot stress how important it is. Very often you will come from some point of, you love your ideas, you love what you think you can make with your experiences, but if you go to this point about thinking of market and commercialization, then you have to envision who is going to be your customer and what are his or she's needs, and try to engage and to get to that level of conversation. So good practice is that in general you learn from the first customer. So your first customer is going to be your ground for making a mistakes and learning. And actually, very often your first customer will know he's your first customer and he will take chances. And that's okay. The thing is that, he will probably discount you in a sense of what he's paying you, or he will probably try to keep part of your code or whatever. They'll try to play things. You have to be smart, but in general, don't beat yourself about being perfect first time. Nobody's perfect first time. There is movies about that. So the thing is that with first customer, it's your learning experience and learn from them, and the whole goal is that then you sell to the others. Then when you go to the others, you can sell, and then you go into that, let's say, professional level. Don't try, they say that the worst marketing is a good marketing for bad product. So if it's your first time that you're selling your code or your game or whatever, and don't try to make it like you've been doing that hundreds of times. Actually, what worked for me for a long time is that when I started, most of the time I would go talk to the people who are the age of my parents, and then I didn't try to convince them that I'm at their level. I tried to play it out as their kid, and they would try treating me as their kid, and then somehow they drop the guard, and suddenly I'm not the guy across the table. I'm somebody they may even want to consider helping. So that is not a bad approach. You don't have to be perfect in the first time. Use it as a learning experience, and then improve your game. And then there's for the closing of this first part, I chose this one quote that I like very much. Actually, this guy is a military genius from the end of 19th century that did the most of ordering of a German army that was what it was in the better part of 20th century. And you would think the Germans plan everything, and the strategy is very important, and yet one of the better known saying of this guy is that no campaign plan survives the first contact with the enemy, which means that you plan, and then you go into the battlefield, and then whatever you planned gets destroyed in the first minute of the battle. So what I'm trying to say with this quote to you guys is that, don't sit too much somewhere, wherever that is, an incubator or your room, or whatever you choose to be your ground for development. Go out immediately. Go out, talk to people. Test your ideas, test the first lines of your code, test the beta versions, get feedback immediately, because it doesn't matter how detailed you plan and how good your strategy. The first, in this case, your customer is your enemy, because you try to win him over. If in the first contact with the customer, it will somehow go awry. It somehow will not work out as you plan. And actually, the more you spend time in some, clean room just with your thoughts, the more lost you're going to be when you get in the first contact with the potential customer. So the more you are in touch with the market at any point of your development, the better you will fare when it comes to real moments. So that's my story about sales not being bad, and why you should think about sales even when you're starting with whatever projects you are starting with. In general, this is, now let's say, introduction to another part, and that is financing. When you think about financing, the whole idea about getting somebody to help you in terms of financing is not just to get money so that you can get to the next phase. Actually, what funds provide to you is in many ways a knowledge about market. So everybody expects you to be engineers that are masters of what you work on. So it's okay to get help for any other facet of business. So when you come to financing, at least to my knowledge, these three are, let's say, generally accepted as levels of finance. I mean, there are left and right maybe in options, but in general you can get a capital. You can get an angel capital. You can then go to venture capitalists for first, second, third, whatever rounds you can get. And then in the past, the holy grail was IPO. What I have to share with you in this line of financing is that let's say 20 years ago or late 90s, early 200s, was that IPO was it. The whole point was to go public and to be on some whatever floor announcing that you are out there with some public shares trading and so on. And actually what I noticed that in last decade or so, actually since 2008, I can probably put the flag there, change, is that IPO is not something that people dream about. because IPO is very difficult. You start going to the bankers, you start going to people who ask a lot of different questions. It's a huge group of people that you have to do what they call dog and pony show. You have to prove that you are a good company. You have to have everything in order. By the time you come to IPO, they expect you to have experienced CEO, good financing. It's an incredible task of getting to this point. And what I've seen in the last decade that is happening a lot is that you find a big technology company that's a bit lost about what's going on in the market. And trust me, there is a lot of them. You can put in that bag most of multinational companies that we admired for better part of last century. So all the guys with 2 letters, 3 letters, not to be nasty to them, are lost. What is cloud, how to deal with the cloud, what are digital transformations, what I can do there, who is buying my iron, who is buying my databases, what I license. They are lost, but they have tons of money yet. So they go around looking for guys with nice projects and nice ideas, and they buy them. So you have different approaches. You look at HP, and they went out, and if you're not selling yourself for billions of dollars, they don't even talk to you. But you go to IBM, and then you will see that they buy from couple of millions to some, 40, 50 millions, but they on quarterly level buy some tens of companies. So it's not simple, but it's doable. And let's say this is the end game. So let's take it out of Rome immediately. This is when you are really, really serious and what you can do. What probably is more logical to talk about is this angel capital and how to get to it. And actually, I get surprised of how people very quickly discount some things here in Serbia. We have a tendency of thinking that we know the best, and not only in Serbia, but I can actually add this to Balkans, because my previous position was that I was running a multinational company in 10 countries of Balkans. So trust me, you've seen it all on this neck of the woods. And it's very similar way of thinking. And we tend to discount something that is very good. If you look at the starts of all these giants of today's, let's say, technology world, Amazon, Google's, Apple, and so on, first serious money they got from government, literally. You will hear a lot from Americans talking about free market capital and so on and so on and so on. But then you look at these giants, and then you look at the first financing that they got. It's some development fund, some SMB fund, whatever, and it was really coming from government. And you will be surprised, but even in Balkan countries, governments are having, these funds. Okay, I think that Apple's first fund was $500,000 that they got from government. So you will not get $500,000 anywhere in the Balkans. But you can get, and I'm serious about, you can get 30,000, 50,000. It's possible. And it's not actually that you need, to become a member of the party anywhere in these, funny countries of ours. But literally you have to be well informed, follow it, what's happening, and look for it. My good recommendation is in Serbia, this unemployment agency is from time to time have donors who run programs like this. It's not anywhere public. It goes quickly, but it's possible to get it. There are some strings attached, but these strings usually are not well thought of, and they don't bind you too bad. Another good point for this angel capital is diaspora. So now I'm talking from the point of the guy who lived 7 years abroad, and is one of the few who came back. Actually, my favorite sad story is that since I was studying in Boston, and MIT, has a great sports facility, but as you can imagine, people at MIT don't do much sports. Guys from Balkans were playing basketball at their courts, because it's easy to access and nobody plays. And we used to play 5-on-5 basketball, and there was usually at least 4 to 5 teams. Out of this group, I think 2 or 3 guys came back, in the sense of came back to live back in Balkans and not staying anywhere. Except one guy did a great thing. He was somewhere from the coast of Dalmatia, and he organized his village to start making pomenada, which is like a grinded olives or something like that. And even though he's MIT engineers, he caught the way of craze for the healthy food, and he's exporting this pomenada to all East Coast United States, lives in Miami, has a Dalmatian restaurant, and he fared the best of all the guys. So, as an engineer, you don't have to just do the code or do engineering. Pomenada, if it works for you, is fine. But anyway, back to finance. Most of these guys who stayed out there are, let's say, well off. They're okay, and they get organized not for sake of nostalgia or for sake of whatever good human thoughts. They got organized into these angel funds, and I'm not joking. I know 3 of these groups, informal groups, where every person pitches in $10,000 or $20,000, and for some professional in states that we're not talking about huge money, even you get a tax reduction if you do this officially. And then you find one guy who is your point man, and he tries to distribute these angel funds. And they, in general, function in a way where, they expect if you come to some investment fund and they start investing into you, that they get money out immediately. So that if they give you, I don't know, $50,000, they will get back, I don't know, 60 or 70 when you find a fund. So this is the fair proposition. Funds actually, when they see this, takes you more seriously, and this is I think a good way to get to the angel capital. And then there are companies. Again, story from my past, when I started in biotech company that was developing protein chips. It was founded by 3 professors, and these guys had some very good technologies at the time for what this was called protein evolution, or actually from the database of protein actually to choose the right protein that binds to the certain other protein. And this was it is still strong diagnostic tool. So for example, if you want to cure cancers, you find what blocks receptors for proven pathways, protein pathways for the cancer development. And they did some novel technologies in this area. And what happens is Adventis at that time approached them, gave them $30 million over 5 years, $1 million, and told them, can you further your study? And I was there for 3rd, 4th, and 5th year of development. And in 5th year, I remember Dirk and Uwe came and spent about a month with us, shadowed us at what we're doing, and said, you're a great group of guys, and went back to Germany. And then management got a letter saying Aventis is not thinking anymore about going into biological medicine, but rather into some other direction. Thank you for cooperation with us. And that was it. Okay, we ran into a problem. Okay, let's find a new financing. And then it was a very difficult path of finding a second round of financing. But what I'm trying to say is that there are companies out there that might find your way of thinking interesting and put you in some what they call a development pipeline of their projects, and give you some serious money for this. Because talking to these guys back at the time, this 5-6 million a year was for them nothing. It was a part of some multi-billion-dollar R&D where they say, okay, this much we are going to give to our scientists, and then this much we are going to disperse to various groups. Actually, it was the funny thing, and you said now think, okay, this guy was in the United States and he's telling us this story here in New Belgrade. But in June, Saga was financing, or actually was part of the conference for BI at the Faculty of Organization Studies here in Belgrade. And the funny thing is that we gave the money for lunch and dinner. It wasn't, we gave the smaller part of money. The better part of money came from American Naval Research Office. So these guys get money to finance conferences and other things around the world where they want to see how people think on certain topics. So they organized the event here in Belgrade where most of the presenters are from Balkans, to just show their study about BI and data science topics. Of course, there are some people from Balkans involved in this process, but in general, these guys do this all over the world. So what I'm again trying to point out, if you reach out, if you think in different directions, there are money out there that you can easily find. And now since I am working for the company that is a commercial oriented, and we are owned by fund, I felt obliged to give you example of what our fund that bought Saga is actually doing. So Usually these guys for funds, they have some topic. They don't just fund good ideas. They find the group of ideas that they like. Nowadays, digital economy is something that is hot. Security is something that is really hot. Security is a big topic. So you pretend that you develop a software for security, the guy will probably flock to you. And there are now numerous funds who are trying to make portfolio investments into security products. Digital economy is still something that is very interesting. When I say digital economy, that means doing this digital transformation and opening the channels from typical sales channels when you have today to these digital channels where you can do your business online. And you might think that what is out there to digitalize further, and then you take the following example. So you guys know about Facebook, Viber, WhatsApp. How many of you heard about WeChat? Excellent. So I don't know how impressed you are with them, but I'm mightily impressed. So, okay, there is a political part of the story. So Chinese people said, okay, we don't let these guys that I mentioned first to come and use in between our people. We don't want any Chinese Spring or whatever, but we understand that we have to make some messaging platform for China, and they made the WeChat. And they made the WeChat in 2012. And why I'm telling you this story, because it was a typical messaging service, very much like Viber and Facebook. And then in 2014, for Chinese New Year, these guys did something revolutionary. They say, don't send present for New Year to your cousins and friends because it's a huge logistics. They get lost and whatever. Just send them some money through our service so they can buy something. And two years ago, they started with this financing part of their messaging application, and nowadays actually people pay more with WeChat than with their credit cards in China, because they have, let's say, I'm translating this to myself, they have their own currency that you exchange, and they build some hundreds of thousands of e-commerce sites where through this application you can sell things, and you can exchange values, and you can change the money. And actually they convince people something that is like a holy grail to every bank in Western world. They convince people to give them their credentials of their credit cards. So you pay with your phone through WeChat application if you are in the store. So it's an equivalent of the e-wallet. Again, why I'm saying this story, because there's huge way to go. Yesterday I talked to Viber guys about how we are going to actually use the fact that in Serbia there is 3.2 million users of Viber. In regions of Southeast Europe there is 33 million users. Around the world there is 800 million of users. So there is a platform with a lot of people come. So for type of guys like myself, how I engage these people to spend money. And this is what the New Frontier Group is trying to do. How we engage people to spend money through digital platforms. Except that this group of people are seniors with a lot of experience and apparently a lot of money as well. So they come and they finance you, and they have something what they call super smart money. And when they give you financing, what further they do for you is that you become part of their network. Currently there's 14 companies in this network. Generally this is like Eastern Europe and Russia. And first of all you start exchanging knowledge of between these companies. And okay, so you think, okay, Saga is having 50 million euros revenue and has 300-400 people, and of course these guys are going to look for Saga. But actually this guy bought a company in Bulgaria that was a few guys working on gamification products for portals, so that product get included into product of another company for, let's say, HR matters, so that when you have a portal for HR, it's not boring what you think about our company, do you hate CEO, or what you think about coffee, but rather that you make a product that is like a gamification HR internal portal. So it doesn't matter what's the size of the company, investment funds, if it's a good idea, will look into you. And then you connect to the markets through these other companies in the group, and you get financial security because they finance you that, whoa, I've been talking a while, huh? So thanks. So this is a whole matter of they give you know-how how to function at the on the market and function with the customer. So what I can tell you about financing is do not die trying. It's not point. You fail many times before you succeed, and failing is okay. Failing, I played rugby when I was a kid, so in rugby they say what doesn't kill you makes you stronger. Life break something, but it's okay. You're what is fine. So out of the whole become part something. This whole story about people don't if big of you are very important. You are very important people. Hold the shop, and then somebody comes out, and I actually know the experience of this Fadata company in Bulgaria. They had a very good product for, and this consulting company from UK came and said, okay, we need to include with our offer, and they gave a lot of money to founder, and the guy was very happy. In the evening, in the morning, he came to work. They packed his stuff, his table, and said, thank you, don't come anymore on our premises. He's like, but how? No, we don't want you anymore on our premises. Literally from the day one when they took ownership, they told the guy, don't come to the premises. If you want to meet us, let's go have a lunch. We're going to talk to you, but we don't want you to be in touch anymore with development teams, with anything in the company. We took the picture of your company, we see what is good, what is bad, and we think your influence is not needed. They probably didn't want to tell him that his influence is not what they want. So, you get into problem when you sell your companies, and it's quite important before you get to the point of financing and talk about sales or whatever, to be clear about your expectations. And this is where I come to talk about Saga. So Saga had 3 major owners, and for better part of their lives they've been Saga. You can take them out of Saga, you can't take Saga out of them. So when these new frontier guys came and bought a company, they had a real issue about what they're going to do to it themselves. And that what happened in the next 5 years of this change of ownership structure is that company was having really hard time, because most of the energy of owners and which was in the same time management of the company went into internal strife. Who is going to make decision? Who is going to influence people? Who is going to, make financial ledgers? So, at some point, obviously somebody called and said, hey guys, this is waste of time, energy, and money. And then they said, okay, let's get the professional managers, and that's how I got in the story. But I'm meant to talk about this, but now, because the other guy is supposed to start fairly soon, I'll cut it short. The whole idea, I hope to all of you who are having your own business, that you're going to the point you're going to sell it, because I think that's the point. And I admire people who are serial entrepreneurs, because that's great. It's summoning the energy to have more than one company is, I think, something to look forward, not to just have one shot. Because nowadays, because I cannot organize my time, I mostly run by myself, and I run half marathons. I admire the guys who run marathons. 100-meter dash, it's great. It takes a lot of steroids, but it's very short. So, selling a company is okay. Starting all over again, it's okay. Selling out, as I said, is not bad. So I hope I gave you some insight of some topics that are ahead of you, and if you're thinking about setting a company, or if you are now working on something that can be commercialized, we are out there to cooperate with anyone in that sense. Let me give you my sales pitch. So if you have ideas and you want support, we can be maybe the company that you can work with. We are in a very, very broad field. We work with finance a lot. We work with telcos a lot. Obviously, we are from Balkan, so we work with public sector as well. We are trying very hard to work with the private company, which is difficult because you know what the situation is in this vertical. We work in 5 countries around Serbia, beside these other 14 that through New Frontier we worked as well. And we try to do a lot of cool things. We have 5 people in our BI sector. We are now forming a group that is going to work on bots and this data mining, machine learning things. I do believe that this thing will commercialize very quickly, and then in 2-3 years we are going to see how their bots doing many different things. I don't know if what these guys said in a paper, 43% of today's professions are going to be annihilated by machines, but certainly a lot of things out there will be looking different in just 5 years, and we are trying to catch this wave, and I think we are well positioned because cost base here is not so high, and we have a lot of talented people. So I'm just trying to give you a taste of what we are looking in right now, beside the fact that, I don't know, we're finishing right now the whole software for treasury, where whole 750,000 of Serbian public officers will get money through our software, and I keep repeating to myself to get used to it because it scares the hell out of me. But we do a lot of complex, good stuff, and we look always for partners, so to use the stage to send this message. Hope it didn't bore you the hell out of you. I hope I gave you something interesting to think about. Sales is not bad. Keep talking, and it's fine to sell out. Thank you.
So hi everyone, I'm Clemen. I'm a developer and developer advocate at Relair. That's a Berlin-based company in the field of Internet of Things. And the plan for today's talk is to talk about one of our ongoing projects in cooperation with Cisco and CSIRO. And the project is about bee population monitoring because the population has been in steep decline in the past decades. And scientists don't know really why, and they need more data to research it. And this is where we come in. And I want to use this project also to tell you about so-called fog computing, which is an idea to push more computation and intelligence towards the edge of the network, instead of having it centralized in the cloud and do everything in the centralized data centers. I'm going to tell you what's the advantage of this kind of network architecture and what are the components of it. So the plan is to first just briefly mention what Internet of Things is, just because I assume you have different perspectives on it, and tell you what exactly we do at Relair, so you see where we're coming from and where our perspective is coming from. And then I'm going to go into the bee monitoring project, how it started, why it started, what was the first step, and what's the current steps. And then I'm going to transition in more general talk about fog computing. Okay, let's start. Internet of Things, depending on your background, you have probably a different idea of it. If you come from a business background, you probably see it as a container for all the new business models and services that having sensors and actuators everywhere enable. But if you are more from an engineering organization, then you see it as an infrastructure that can enable all those services. So you're focused on the infrastructure. And the infrastructure, with infrastructure I mean both hardware and software. So you have companies focusing on developing low power, cheap microcontrollers, companies focusing on developing new radio technologies, low power radio technologies, companies developing new protocols, new standards, and routers, gateways, software for them, software for the cloud, IoT specific databases, analytics, and applications on top of it. And we at Relair, we are focusing on the middleware, the software between the physical devices, the sensors and actuators, and the user application. So we're focusing on the software adapters for all kinds of different protocols, the industrial protocols, Modbus, S7, the IoT specific protocols like CoAP and MQTT, and also legacy protocols, the protocols to interface with old machinery in the factories. Then we are focusing on the software on the gateway, which translates that data and sends it to the cloud. And then we have software that stores the data, does some analytics, integrates it with third-party services or your custom application. Okay, so now we have a bit of a context and we can go into the project. Let's first talk about why would you monitor the bee population. 1/3 of the food that we consume each day relies on pollination, and bees pollinate 70% of world's crops. And at the same time, bee colonies declined from 6 million to 3 million in the past 70 years. And here you see the problem. And researchers, they don't really know, they cannot pinpoint what's the exact reason for it. And for being able to study it better, they need more data. And possible reasons for it are parasites, pesticides, malnutrition, agriculture, intensification in general. And we came in with Cisco. Project was originally started with Cisco as Corporate Social Responsibility Project, and it's part of the global initiative for honeybee health. And one of the partners there is also CSIRO, the federal government agency for scientific research in Australia. And different organizations have different approaches to monitoring beehives, not beehives, but bee population. And for example, CSIRO, they have an interesting approach. They put RFID tags directly on the bees, and this is a small sensor, 2.2 by 2.2 millimeters, which they put on frozen bees, and when they wake up, they fly away with the sensors on it. And then they put a lot of checkpoints in different points in Tasmania, for example, on beehives and in other points, and then they can model the exact mobility patterns of specific bees in 3 dimensions. And they already have thousands of bees tagged like this in Tasmania, and it's a very precise approach that enables studying the bee population patterns quite well, because they can know the exact patterns of a specific bee. The disadvantage is that it's not very scalable and it's not cheap. Your average beekeeper won't implement it. So it's the data sets are not going to be so big if compared to a solution that any beekeeper could implement. And it's also highly localized, so it's only in Tasmania. So this is why we approached for a different angle, and we plan to we're monitoring beehives. So the plan is to have multiple different sensors on it. We started with some. So the plan is to eventually have weight, humidity, temperature, thermal imagery, and audio signals off inside of the beehives. Because, for example, by specific frequency patterns, you can know how many bees are in the beehive, and also supposedly how happy they are. The first steps that we did were a small prototype that we showed in Cisco DevNet event in Las Vegas. And this was just a prototype to ideate with the community there, because there was also a big hackathon where people gave us a lot of feedback and ideas. And the first prototype was with a chip called ESP8266. It's a not very industrial chip. It's a maker's thing. And it has a ability to connect through Wi-Fi. And we connected temperature sensor, humidity sensor, noise level sensor, and weight sensor on it, low cell. We connected it to Wi-Fi router and just relayed that data directly to our cloud, where it was stored, exposed through APIs, and so people at the hackathon could interact with it and also try out changes on the hardware. At that hackathon, we also made a small mock-up of the CS Iris approach. So we put some devices that were bee-like and were vibrating on this green plate, and we put a checkpoint every time when they passed by. Data was sent to the cloud. And this was, again, mostly for starting the conversation with the community there. But would this kind of approach be suitable for a beehive that's not in the middle of Las Vegas or in a hotel? It's unlikely, and we want to have a solution that would be easy for beekeepers to implement, and that it would also be cheap. And most of the beehives are in remote places where you don't have a plug for each beehive, and most of the beehives even have unreliable networking. So you don't have a Ethernet plug or Wi-Fi there. Sometimes you don't even have a cellular network there. And for this kind of environment, you need to implement systems that are defined usually as constrained devices. So you have to implement the nodes there that are low power. That usually they're run on batteries, maybe for a year or even more, and that are very cheap, and they have consequently limited processing power. And for that, you have to have a different approach. You cannot just use something like this because it's not really suitable for all these constraints. And the changes that we did is we are changing from Wi-Fi to more low power radio technologies, to 15.4 based radio technologies to 6-low PAN, and we're changing the protocol from MQTT to CoAP because we think it enables us more features. And we're also experimenting with the wide area network called LoRa because we have it on some other projects and we had a success with it. And the plan is also to push more smartness to the edge of the networks. This is probably new. I'm going to explain each of these things because maybe for someone this is new here. So what's 6LoWPAN? 6LoWPAN means IPv6 over low power wireless personal area networks. So these are radio technologies which enable you to have more low power nodes that can last on battery much longer than if you use Wi-Fi. And 6LoWPAN is an adaptation layer for IPv6 over those radio technologies. It defines encapsulation and header compression, and we're using it on one board called Zolertia with the operating system called Contiki. It's an embedded operating system that supports this kind of stack. We're also looking into 5-wave and Riot as an operating system just because the other embedded chip is much cheaper than Zolertia, and this is one of our goals as well. It's not so mature yet though. This is why we're still using Zolertia. What is LoRa? LoRa is a radio technology, wide area radio technology that was developed specifically in mind for low power nodes on the edge, so they could also live on battery for a very long time. And the range of LoRa in open environment is really, really long. It's 15 kilometers, up to 15 kilometers or even more. And if it's in urban environment, it's less, but you have a really good building penetration. And this is quite important for some use cases. It has ability to run in unlicensed bands, so that means you don't have to ask your government when you implement this kind of infrastructure. So you can have your own network and you don't have to pay to some operator if you use an unlicensed band. You still have some constraints, but you can do it on your own. It supports high density of nodes, and LoRa defines the physical layer, the modulation of the radio waves, and it was developed by one company called Semtech, and every time you buy a small LoRa chip, you pay a small licensing fee to them. You have open solutions for implementing this kind of software on chips that you buy, so you can easily use LoRaWAN, which is a MAC layer on top of it, and enables you to exchange. It's a protocol that enables you to exchange data. You don't have to create your own. And you already have communities that implement an open network in different cities. For example, in Berlin we have already 6 gateways with the Things network. It's a community where anyone that joins it, they can bring that gateway to the network and give other people access to the network. I've also said that the plan is to push more smartness to the edge of the network. So what do I mean with this? So usually you have, like in normal IoT product, you have some nodes on the edge of the network, so sensors and actuators. Then you have some gateway which acts as an interface to the global network. And on the cloud you do the computation and storage of that data, and you also then build integration with third-party services and things like this, or expose your data through APIs. So if we take an example of that first prototype that I showed you with the ESP that we showed in Cisco's DevNet event, you have some sensor node at the end that acquires data from the sensors and sends it every 10 seconds to the gateway, which was just a Wi-Fi router that relayed the data directly to our cloud. An alternative to this approach is to first add some intelligence directly at the edge of the network. And instead of sending data every 10 seconds, you filter it already there. So instead of sending 25 degrees, 25 degrees, 25 degrees, you only send it when it changes for 1 degree or something like this. And then on the gateway, you don't just relay that data to the cloud, but if you have a good idea of what exactly you're looking for from that data, then you do the streaming analytics already on the gateway, for example, and send only the data of how many bees are in the beehive and not the frequencies, for example, or not the data from the checkpoints, like in CSIRO's case, but you send the exact mobility patterns of the specific bees. And the idea behind fog computing is exactly this, is to decentralize the computing power from having it in the centralized data centers and push some of that intelligence to the local area network. So here we have one definition. Fog computing is a highly virtualized platform which provides computation, storage, and networking services between the end nodes and the traditional clouds. And what takes care for this local computing in the local area network? It depends on your use case. If you're Deutsche Bahn and you have a lot of infrastructure and you have enough IT support, it can be server racks in some of the stations in the country. If you don't have such a huge infrastructure, or you have a smaller use case, you can have a specialized edge gateway which has some storage capability and some more processing power than the normal gateway. Or if you have a very simple use case, you might even use a system on a chip such as Raspberry Pi. So fog computing can come in many shapes and sizes, and the idea is only to decentralize the computing power. So what would be the typical components of such network architecture, let's say it? What would you have on such gateway or in local area network? First, you would have some kind of protocol translation. So ideally, you would have a pluggable architecture with adapters for different protocols. And ideally, this would be extensible. So if you work a lot with industry partners and they have a lot of legacy protocols, you want to be able to easily add another protocol on top of it. And you want to also support newer IoT protocols, because this enables you to have more low power demands for the attached device, for example, if there is a newer radio technology, and enables you to have lower computing demands for attached devices. And in turn, it also enables you to have lower costs of the devices, so you can have more variety of the devices and protocols in your local area network. Once you have the ability to interact with all these different devices, you probably get different kinds of data in the gateway, and you want to do some kind of sensor data translation that translates the data into a uniform format. And this can again be done with some intelligence. So if you use some standards such as IEEE standard for smart transducers, then you can use, this is a standard that's kind of like a data sheet for each of the sensor. And sometimes this can be stored directly in EEPROM of the sensor, and your gateway reads it if it's a physical connection. Or it can be downloaded from the net by the gateway itself. And then you know what's the range of the readings that you're supposed to get, what are the units, and then you can add that metadata automatically to your sensor readings. You can add additional metadata, and you have some standards for it, such as Web of Things model, and you can, that metadata can again be specific to the device, or it can be also metadata specific to the area environment in which you operate. Once you have the data in a uniform format, you store it. You can store it as a long-term data. You can have a long-term data storage, again, if you have a bigger infrastructure with server racks, for example. Or you can only have it temporary data storage, which enables you some local logic and data preprocessing, for example, for streaming analytics. You can implement data replication, database clustering, so all the ideas that you can take ideas from that already exist directly at the servers on the global internet, used in centralized data centers. And another quite important thing that you can do if you put more intelligence into a gateway. You can enable local logic, so control loops for rapid response industrial systems. You can implement it directly in the gateway. You probably have to, not you can, because you need low latency and you need higher availability and reliability. And this is usually not just in industrial settings, but also at home. You don't want your lights to be triggered through the cloud and then back to your house. You can implement it in some kind of way of a rule engine where you can do some filtering of the data or some, again, local logic. And if it's filtering of the data, you can have it connected to your cloud platform, and you can manipulate that rule engine not just locally but from your cloud. Streaming analytics I mentioned before, and also local audio and video streaming. If you again have some media that can be streamed in the local area network. On the other side of the gateway, on one side you have the adapters to different devices and the translation. On the other side you have the transport layer that connects to your cloud platform. And that takes care for transportation of pre-processed data, for service consumption, for encryption, decryption, authentication, privacy, and the adapters to whatever your cloud uses, WebSockets, sockets, or HTTP. And ideally this is again abstracted so you can interface with different cloud platforms so you don't have to use one specific one. And having data, having devices kind of decoupled from the global network is important again for security because it reduces the attack surface. So in a way it's easier to keep up with the evolving security protocols. Think about that you have a protocol that you implemented on the device, specific IoT protocol, and then you have to update the implementation of it, or the standard gets updated. If it connects directly to the cloud, then you have a big problem. You have to do it probably very quickly because anyone from globally can attack you. But if you have this protocol only used in the local area network, then the attack surface is limited to the gateway and the thing. And this kind of also mitigates the vastly different expected lifetimes of IT and things. So you can still take care for updating of your local logic and streaming analytics and things like this very rapidly, but in a way you can be slower with the things that happen in your lower area network, local area network. Device management, it's again a big thing when you have implementing such a infrastructure. And you can think of it as a registry of all devices that interact with a gateway. And devices, in our opinion, should be added and removed, updated locally. While firmware updates and things, obviously, of the gateway can still be done remotely. And this, I just gave you a general idea of what the components you would have to think of when you implement this kind of thing. And you can implement it microservice based with event bus that takes care for the messaging between the services. And the components, if we look at them again, is on one side all the adapters to different radio technologies and protocols. And then you have sensor data translation, which puts the data in the uniform format. Then you have local storage and local logic, such as streaming analytics or rule engine. And then you have transport layer that takes care for sending that data to your cloud platform. And that doesn't mean that your core service won't be the cloud anymore. You might have majority of computing capabilities still there. But it can mean that the local area network will become your main thing, your core network, in case of larger companies. If for example, again, Deutsche Bahn, if you're very concerned about the privacy issues and issues like that. So that was actually, I was pretty quick. That was actually my plan to just tell you a general idea of the file computing and introduce the B project. And we're open for questions with Antonio here. And if you're interested in the cloud platform, you can still check out how we do the device modeling, things like this. And we're planning to also give these things away if you use this link.
Okay, so if you have questions, please go forward. What you've shown here is a work in progress. We started this project in May with Cisco, and even inside Cisco, they were not very convinced about it, the management. But after the event we had in Las Vegas in July, they changed their opinion, and now we have full speed ahead on this project. So, but it's still a work in progress. So as my colleague explained, the people in Australia, they've been working on this for 2 years, and their approach is totally different. It's about the RFID tags. In fact, they're working on a second version of RFID tags because those are passive, which means they have a huge reader at the entries of the beehives. But they're working on the second version, which are active and have things like GPS. And how do they power the GPS transceiver? They harvest the power from the wings. So as you see, this is very cool technology, but it's patented, which means that only for researchers will be available. And if you're a small bee farmer, this is not accessible to you. So our approach is to make it accessible to anyone that has 1 or 2 beehives, or if you have 500. And this is what Clement talked about. So go forward.
And yeah, also the plan is to have it open sourced. I forgot to mention that. The first prototype is already on the GitHub, but the current iteration with Zolertia is not yet. It's not prepared yet, actually. Yeah.
Yes, everything is open source. So we have a repo in GitHub. So if you want to work on this project and contribute, you're much more than welcome to do it.
I have one question for protocols. So, why is the reason why you took the co-op, am I right, instead of MQTT?
So, one of the reasons is ability to have a bit more features, such as resource discovery, and I think the major reason is actually to run it over UDP and not TCP. And for only sending a few messages every now and then, we think it's a better approach to not have to have a TCP connection for the small message that we send. But there are very different protocols, different paradigms. Like one is PubSub, the other one is REST. So it depends what you like and depends on the use case. And we want to use CoAP because we also want to use it in majority of our projects that are maybe more complex in terms of use cases.
Yes, I just want to add one thing, which is CoAP has a thing which is called an observer pattern. And this allows you to have a bunch of clients subscribing to a particular data feed. This exists in CoAP, like is an addition to the protocol standard that was done afterwards. And we already use this in a project. So CoAP tries to be RESTful. But to do this observer pattern and to be useful for an Internet of Things context, what they did is that you could have a situation when you have a sensor node, and you can say there are a bunch of devices that are subscribing to this data feed. Could be, for instance, the temperature inside the beehive, and only wake up the device, that the sensor node, when the temperature changes more than 3 degrees Celsius. So what happens is that you can have the device in a deep sleep, and then wake up, and then you send the data to these devices. They will get notified. So you cannot do those. You can do these types of things with MQTT, but it's more complex because then each of the devices will have to subscribe to the feed, and this ability to have the observer pattern working, which is like their approach, the CoAP people approach, the IETF approach to having a PubSub architecture, I think is much more interesting and more adapt to constrained devices and to saving power, which is always a big concern here.
All right, so the main reason is power consumption, am I right? Or one of the main reasons.
Not only that, is the fact that it's RESTful, okay, so you could have, in fact, with the observer pattern, what you have is a server that runs on the sensor node. While if you have MQTT, usually what you have is a client. There's also one issue with MQTT is that the broker is a single point of failure, right?
It enables more features, yeah. Also, like you, like Antonio mentioned, you don't have to go through the broker. So even the nodes itself, they can communicate directly between each other, which is maybe not so necessarily in the case of this project. But like I said, if we might want to use something that's extensible to multiple use cases.
Thank you.
Okay,
No
then
more questions? Thank you very much.
thank you.
I am muted. So this is a replacement talk called Drop Database Galactic Story. But even though it's replacement, I think it might be quite interesting to you. So like 2 days ago, I was doing a talk about Lambda Hardcore, and that was very useless, but I hope interesting thing. So this one is opposite one. No, it's completely useful and uninteresting. No, I hope not. You will tell me. So let's start. Short about me, my name is Jarek Ratajski. I am developer, wizard, an architect. So I live in Lucerne. That's a city, below the mountain on the lake. And on the mountain there was a dragon. You get the point. Of course there live dwarves there. I work for CSS Insurance, also known as CSS Versicherung. So that's my, I would call them Pokemons of technologies I play with. All of them I hate, I think, and that's my email and Twitter, so if you have some thoughts, want to share something, just, do it. So, before I really start with my presentation, I want to introduce you some concept. Multiversum, who knows what is this? This is a physical concept, you know. As 2 days ago, this man knows everything. But okay, so, very easy, because it's needed for a presentation. You know what this is? From physics, chemistry? What's this?
Electron orbital.
So, yeah, so, oh, you are very exact. So orbital, it means a probability density. So if we are trying to spot an electron in some kind of atom, we may spot it in this area. So the more dark it is, the more probable is to find it there. So it like to show you, we may spot with some probability the electron there, or we can spot it with even better probability there or there, and it's quite unlikely to spot it if we are doing observation somewhere in this white area. It's like this. So this is this randomness of quantum theory. You've surely heard about it. So let's pretend we are doing some observation and we spotted electron there. And there are some people that hate this idea of randomness. How can it be random? There must be some kind of machinery inside. But till now, nobody found this machinery. So it seems to be totally random, but why there? So there is one interesting answer to this problem. The answer is there is no randomness. In every moment we do such observation, what is happening with the whole universe? It forks. You know the Linux instruction fork? What it does? It splits the process into two same looking processes that go farther the same. So in the moment we are doing observation, the whole universe forked. And we are like this child process, one of them, and we see the electron there. But there are some parallel universes created, forked. For them, they see their history different. They see this electron in other places. So like, this is a way to avoid randomness. There is no randomness, that's only forking of everything. And if you think about it, it's quite funny because maybe that was one sample, electron was there or there, and the next moment we do further observation and maybe we observe it in other place. So this moment there were this story of this atom was forked 4 times. That's simplification because it's not the story of the atom that's forked. This is the story of the universe, of the Earth at least, and maybe more. So in every moment, only because there's one simple electron, we fork everything. It's huge concept, very interesting. And it goes farther. So this theory, multiversum, simply says that the whole universe, really, is because of those observations made on the so small scale, every moment forks incredibly. That's massive Eber fork of forks. Is it right? Yeah, thank you. The man that knows everything said that I'm correct. Yeah, I'm not really a physician, so for me it's like talking further about the things I've seen on YouTube, in the books, but nevertheless. So it's this massive multi-fork is called multiversum, and what's interesting about this theory is that, and very important, that we only see this one chain of events. In this moment, I see only one chain of events, all others are parallel universes forked are not visible to me. So maybe in one of these parallel universes, because of something happening, I don't know, yesterday at the party, I'm not even doing this presentation at all. But you don't know this. You are lucky because you are here and you see my presentation. Okay, so, and because of that, because we cannot prove those universes are really not touchable, we cannot contact with them, this theory is completely useless. But it's nice to hear about it. But let's go back to the reality. So let's think about something from the real life case. So there is this galaxy. It's quite known, in Poland at least. And there is this guy, is the galactic-wide known businessman. His name is Domino just. And he has idea of creating galaxy-wide pizza delivery. It will be called Galac Pizza. Just normal business, yeah. So let's talk about this business. So we'll be doing some real stuff. So the business is in the galaxy exist like 10,000 planets. Okay, the 10,000 planets where the creatures, aliens, eat pizza. There are other planets, you know, galaxies are huge, but there are no beings there interested in pizza, yeah. Poor aliens. But 10,000 planets surely can order pizzas. And there are 3 variants of pizza. As you see, the most important one is Hawaii. Who likes Hawaii pizza? Oh, am I the only one? Margarita, of course, and vegetarian. Just not to forget about vegetarians. There are 3 sizes of pizza: medium, large, and extra large. Of course, the small pizza makes no sense at all. So good businessman knows that. So that's our domain. 10,000 planets ordering pizza with 3 variants, with 3 sizes. And by the way, that should be made a very simple system that, alien being, alien creature can order 1 pizza at a time. He can choose, it can choose. For instance, margarita, large, to the planet with some kind of fancy planet name. That is our domain. And there is one more important thing to this domain, because this businessman, Domino, he doesn't like to give money too much. He has only 1 pizza boy with 1 racket. And he thought it might be very smart if there are alien creatures ordering pizza to deliver this pizza first to the most demanding planet. The planet that requests the most pizza should be served first, like this. So in our domain we have some constraint that the pizza boy with this racket should surely, if there is a huge queue of orders, should surely go first, not the first that ordered, but the planets that at this moment order the most pizzas. That's just our requirement. So in this case he would go to this brown planet first, then to the second. I don't know the color because I don't see them, but because they were both, we have 3 pizzas, and that at the end to those not really profitable planet with only 1 order. I hope it's very easy to find out how it works like. So the pizza boy is in fact very, very quick with this racket. You know, that's really cosmic technology, it's a galactic technology, so he made it in no time, like travels back again. The only problem is really the speed of the system that will be accepting these orders and will be used in processing. So this system must be very fast, said the guy. Like, it should be able to process like 10,000 pizzas per second. So 10,000 orders made at least per second should be possible, and this guy should be able to say, I'm taking, for instance, these 3 pizzas from the most demanding planet, and it should totally make this true output of 10,000 pizzas per second. By the way, who is working with systems that process like 10,000, orders per second, normally, among you? Who is working with systems that process 1,000 orders per second? Okay, who is working with systems that process something like hundreds per second? Yeah, that's more typical. In most cases, in this galaxy, boring galaxy, we do things with systems that process some. It's even now then big, 10 things per second, 20. By the way, who is working with Java EE stack? So I was many times trying to tune Java EE systems to process something like, I don't know, more than 10 per second, because it was almost impossible to reach that speed. But we are talking about 10,000. Okay, so right now, why did we have this concept of multiversum? Because we'll be now following the story that happened in two parallel universes. Because I was there, so I can tell you what happened. So there is a normal universe and other universe. And in both universes, there were, the Domino, the owner of the business inventor, gathered the group of coders, alien creatures that can code in something. Normal case. So, and he explained them domain and the requirements and everything. And then developers were asking, how do we do the system? In a normal universe, they have chosen Java. By the way, who is a Java developer here? Great, it's especially for you. And the other universe, guess what they choose, what they have chosen. Plus plus, but they've chosen Java plus plus. We'll go further, what this topic means. Okay, so let's go to the normal universe. By the way, the code, I was able to fork this code on a GitHub, so you can see the code created in this normal universe on a GitHub under this address. So no problem, you can check it later. And in the normal universe, the alien developers started with modeling the domain. What is the domain in this case? You see, it's order. It means the most important object in the system is order. Like, as I said, the alien being, not the human one, can order one pizza at a time to some planet with some variant and some size. By the way, as you see, it's not Java Bean. Who is not using Java Beans anymore? Oh, great. You shouldn't use Java Beans. They are just stupid concept. So this is immutable object, which really is great in working with. But okay, that's another story. And by the way, they added some kind of ID to the orders, because, you know, everything should have ID. I don't know why. Those are aliens. And though that's enums that we need, it's very obvious what kind of... You follow, you understand this code. It's very easy. Nothing really was happening there. So, and then they were thinking about the behavior. What kind of services should they provide? They have first defined the interface for the customers. Long place order for which planet, which variant, which size. As I said, it means for one pizza. So if the alien creature is organizing a party and needs 20 pizzas, this being must order 20 times. It's okay, it's that easy. And then it gives back some kind of ID, whether it's needed or not. And then they were thinking about the back office. By the way, I forgot to tell you about one other thing. So take orders from Best Planet is something for the pizza boy. So every time he goes back with his racket and he is about to serve some other pizzas to transfer them, he uses this function and gets the list of orders to Best Planet and travels to this planet faster than light and goes back, and then again uses this function. And by the way, I've skipped this requirement. It should be there somewhere. Let's go back. This below. The Domino says that they want to constantly look at how many standing orders are there. Maybe the queue is too huge. Maybe he will need another pizza boy or whatever. And he will be checking like 10,000 times per second. And by the way, his wife also. So it makes 20,000 per second. But okay, 10,000 per seconds are needed. So we'll go back again to this story. So because of that, there is this count standing orders that returns along. So how many orders are on the queue waiting? Simple like that. I hope it's easy. So they even made a global interface for something called Galac Pizza Service with Galac Pizza Delivery and Galac Pizza Orders. Like this. So they are starting to implement it. So how Java developers can store orders somewhere? So like for every planet, I should know how many orders are there. Somebody has an idea? Give me ideas. Multi-map. Okay, so yeah, that was their initial idea. How did you know that? Okay, we are working together, almost. We should be. He reads my mind, really. Yeah, you've been there. Okay, so that's kind of a multi-map. We have a name of the planet here and list of orders. And that's a hash map. Who knows the hash map, by the way? Great, so it's easy, yeah? So they started with this, but it wasn't, in this implementation, it wasn't very useful, because working with this list directly was kind of not pleasant, so they created some other supplementary class called planet orders. It simply hides this list. So planet orders is like name of planet and orders, and you get the point. And assign order that adds to this list something. So because in Java it is not that easy to work directly with this list, this implemented, so with that kind of utility object it was easier. So, and method is empty. So how was place order done? Very, very easy. You know, place order, we have a sequence that is just a long, we increment it, we create new order object, then we call method assign order to planet with an order, and then we return ID. So let's see how this assign order to planets looks like. We have an order, then from these orders we call funny method. Who knows compute if absent? Yeah, you should know that, because typically in Java what would you do? You would check with if there are orders to this planet at all. If you find this object planet orders, then you will add it to this list. But maybe there were no orders to this planet before, so you get a null. Null is the bad thing. So then you would what would you do normally? If get from orders is null, then create new planet orders, put it into this map, and then assign to it. That's quite few lines of code. You can replace them with this small construct, this method, compute if absent. It exists since Java 8. You say to which key, and what would you do if the thing isn't found there? So compute if absent works like that. We look for the object with this key. If the object is not there, automatically will be created here and added to the hash method, then returned. So it makes our code very easy. We don't have any ifs. It's perfect. Really, that's functional solution. It's possible with Java 8. It's great. You should know this. Okay. So then they were thinking about this counting orders. How many are in the queue? So initial idea was to create another long thing, but then they realized might be a problem, so they used atomic long. Who knows what that atomic long is? Yeah, great. So generally it's safe for the multi-threading use. So just like long. So in this place order they increment it simply like that. Why it's atomic long I will explain later. Why the other long is not atomic. So then they were thinking, okay, placing orders is easy, but how can we retrieve which planet has the most, at the moment, he's demanding the most pizzas? So should we go along this hash map, along all this list and just sort them? Of course it would be possible, but it would be slow. They in fact tried it and it was slow. So they realized they need some kind of a structure, something that they can easily always take the best planet from. You know this structure maybe. Who knows that's magic? In fact, it's not magic. Yeah. Data structure that you can put objects and they automatically are sorted inside. So every time you pick from it, you get the best one. Then you take another best one. What binary? Yeah. And in Java, there is a class that exactly has this implementation behind. What? Okay. Once again, what? Exactly. I am talking about priority queue. So behind the priority queue, you have this tree, but the priority queue interface is like really put something and always take the best one from front. So it's interesting. You are Java developers, and only one of you know about the priority queue. Think about it. It's quite long known class. You've never needed before priority queue. It's interesting. And you never needed before compute if absent. Of course, compute if absent is something new in Java 8. Okay, it's not really that new, but priority queue exists like 15 years. I think it's quite useful, but you never needed that. Okay, so they simply implemented it like that. Every time they assign planet orders to planet, they put this order to the priority queue. In fact, with the whole planet orders. And it would be okay solution. It would even somehow work, but there is a problem with priority queue. Okay, it's not a problem with priority queue. Problem with this implementation. If you have something in priority queue, and we sort by the number of pizzas inside for each planet, such object may not change because these things we are sorting for cannot change. If you put something in a planet in this priority queue, it must be generally immutable. So not the whole thing, but the thing we are sorting. If we don't do that, it mutates. So like for instance, the planet had 5 pizzas, and then we change it to 6. It will work, but will behave not according to the contract. It won't give that, for instance, the best results, or it will be unperformant. So there was a solution for that. I say this is very bad concept to put planet orders that then I later changed. So they created something like planet order wrapper. It's simply like memento. We store how many planets we had at the moment of putting, and it stays like that. So it's very easy object. It's final int. You see final never changes, and such objects we put to the priority queue. Okay, and then I will not explain you all the details. We have more important things, but generally take orders using this was possible. So first on this list, they implemented take orders, like just take all these orders, assign the new array list because we simply clear everything for these planets and return what was there. We have a method, a supplementary method is empty. Yeah. By the way, we mutate planet orders. We don't mutate this exactly these things that is on in the priority queue. So it's like a trick. We mutate this object behind, but not the thing we are sorting. And then here is quite funny code. We take the best thing from the planet's orders. If it's null, then if it's not null and not empty, then we can use it. If it's empty, then we can just look for another. Or maybe we'll, by the way, who is using optional at the moment? Great. You should, in a new Java code, you should never use null on your own. I had to use null here because I am talking to the very old and nasty class designed by some Java developers. But I would never right now design my class so that it returns, the method returns null or accepts null. That's a just bad idea. That's a mistake in 2016. So even here, if I am talking to priority queue, I wrap it so that I don't return null, I return optional from planet orders. Learn us, you shall never return null. A lesson. Okay, but then they made it, this code, I really skip it. So it was possible to efficiently take the best planets because we had some other supplementary construct. We are not working directly on this hash map that is our storage. We are working on this additional object, which is, by the way, simple index. We can call it just index, and we use it for searching for the best planet. Okay, so, and by the way, take orders from planet. At the end, if we take, I don't know, 6 orders, we decrement this orders total. We subtract something. So counting orders, so how many orders are in the queue was very easy. Like we just use this orders total atomic long and we return the thing. It's incredibly easy. So almost done. They even did a test for that. But you may see some problem with this implementation. Who sees a problem with this implementation? It's a perfect Java solution, but might have a problem. Think about putting it on production. Where is the problem? Restarting, because what? Hash map would be, not there. Other problem? So generally, 2 problems. At least I know about two problems, concurrency and persistence. Typical problem. And right now, this group of alien developers luckily had one experienced Java developers among themselves. And they told them, you know, it's easy. How can that be easy? Because they introduced a little bit of magic. A little bit of magic is some interesting thing called persistence controller. It's a class. It's open source. You can find it later on the GitHub. We'll not go to the details, how it looks like. Well, it doesn't matter. I will tell you how it works, because it works very, very simple. So what they do, they had something, they had implementation of Galak Pizza service, but they implemented it once again, but this time with concurrency and persistence. How? But using the other implementation. So how did they do that? Here they initialize this thing. It's not really important, by the way. It means here stays where on the disk it will be written, but it's not important. Let's analyze the place order. What happens? We use the controller. We call the method that is called execute and query. Then we get something core. What is a core? Core is this object, Galak Pizza core, so implementation in fact of the same service that was written in plain Java without any persistence, whatever, on the hash maps. So execute and query work on this simple Java thing and calls place order there. So we only delegate. We don't do anything interesting, we only delegate, put it further. But there happens something. I tell you a little bit of magic, because this execute and query does one more thing. Okay, two, because we have two problems. First of all, this is a lambda expression. And who has used lambda expressions in Java? Lambda expression is an object in Java. Objects in Java you can generally save. Using what? Who knows? Easy way to save something. Serialization. That's a lot of people criticize it, but it's very in fact powerful. I don't really completely like it, but it works. So what they do, they first of all serialize this thing on the disk, so store it. And by the way, they don't store this thing doesn't store the code. It's not code that is stored. It's simply what is stored there is like something like the number of lambda expression, so some kind of reference. In normal cases, just the name of class, and then all the needed parameters, so planet, variant, and size. These three things. So it's like, otherwise it would be simply on the disk that I did place order and with three parameters. That's everything that is needed to reply it to just know what's happening. So this thing is stored on the disk. And then it's executed. Simple like that. So if we take orders from the best planet, it happens the same thing. We first store on the disk. By the way, this time we only need to store what was happening. Take orders from the best planet, no parameters are needed. It just goes like that. So we just say that it was this method called. And one more thing, those methods, execute and query, are completely thread safe. It means only one, in fact, at the time is working with something. So in fact, there is a little bit of code that you can store multiple at a time, but only one is executed. So everything that happens here inside of executed query is guaranteed to be only to be processed one at a time. It's very good because it's then we don't have problems with concurrency. But then you have queries, so at the end we are calling this count standing orders, and you know, queries, you don't have to store anything, you just query, so you don't change the system. That's basically this idea of this query. I hope you see this. So they are saying what they are doing, the counting standard orders, they get the result, and it will be called. By the way, this query is not really needed, you can call it directly, but it was just to make it somehow consistent. So query in fact does nothing. It's no magic there, in fact. That's a typical delegation. Okay, I hope you more or less understand the idea. Let's store what we are doing with all parameters and then do it. And this way, they have at least some kind of a log on the disk, what was happening with the system. Everything that happened with the system is stored in this log. And it was done. Okay? So, this thing, and the normal universe, I call it normal with Java, was done. System was working. We'll go back there later. So let's take a look at alternative universe. By the way, I also stole the code from this alternative universe. I've stolen and inserted it on the GitHub, so you can check it and you can see it. So it was this Java++. What do you think is Java++? Who knows this, more or less, what it does? So who is using JPA in his work, or know how to use JPA? Okay? So Hibernate, other object relational mappings, who knows? Okay. Give me a name. Interesting object relational mappings. For Java, best. Okay, that's more or less the same. It's more or less the same. So this time the group of alien developers tried to model the domain. As the other group, in this parallel universe, they realized that the most important object is order. So in order to preserve, to model order, they created class order. How simple. And of course, in this universe, they believed everything that exists must exist in a table in the database. So they added some kind of magic annotations, like table. And by the way, they needed to use it because if it's SQL database, the table cannot be named order. It must be, because order is reserved keyword. So they had to use it T-order. It's a really nice concept. And then they did it. Okay, we'll go further with this name queries. Maybe you know what's this. It's looking like SQL. And then these implementations look more or less the same as the normal universe. There is only a little bit more magic, like entity, named queries, table, this generator, and this is the most funny thing, because somehow in year 2016, JPA you cannot really do clean objects with immutable. You have always to give at least this protected constructor without parameter. This is really crazy. So you had to fill with some crazy data like nulls for no reason, because in fact this constructor is in fact never used. It's only needed by the framework. So it's really crazy for me. Yeah, why then? But it's not really, because for serialization you don't need it. Sure. Surely not for okay, serialization in Hibernate, whatever, maybe, but for a normal serialization, surely not. So that's the attitude of the guys. They love Java, but they must do everything in SQL. So as you see, at least the other things in the domain were the same. So they even later tried it. So it's MySQL select. You see, it works with MySQL. Great. So because there is a table, it means the system work exists. So they are satisfied. They were working for real this time because they have table. Yeah. So if we go to the other services and things like that, you see some similarities because the way of thinking was somehow the same most of the time. So selecting the best planet, maybe. All of was simple, but how they select the best planet? That was the first approach. Select, blah, blah, count from group by count. Is it okay? Solution. It would work, but wouldn't be they tried it that fast. So they realized they need some kind of another table that would really help them to sort those best planets. So you see the similarity. So they created this planet structure that has a name and a counter. So they can now sort this table, and it was all with this solution a little bit faster. In fact, way faster. So it worked. And then they started to implement. It's this kind of implementation you can see everywhere. It's quite common. I won't go to the details, like whatever you do, theoretically everything in Java, but in fact all that happens in select queries and with JPA, persist and things like that. There is a lot of magic happening there, like for instance, I can show you one funny magic here. Because they realized if there were no orders for the planet and it is executed concurrently, it might be that twice in the same times are inserted the same planet structure with the same name. Then they have, how it's the constraint violation exception because the same name already exists. So in fact they invented functional, very, very funny way to do that. They use this do this function that takes a session, that's a Hibernate session, and with a function that's db command. So they execute this db command, it works, and in case of constraint violation, they re-execute it once again, because this method is looking like, does there exist this row in the planet table? If exists, that increment counter, if not, insert. So sometimes it happens that two transactions see there is no such row, so insert, and both insert the same planet. With this case, you have automatically retrial. So maybe they will do the same 2 times. Both think, okay, doesn't exist. Both insert the same planet with a counter 1, and then one fails because of constraint violation exception. So what happens then? The whole command is restarted, but this time it reads from the database, select from planet with this name. Oh, it's there! So right now it works. So it's a really nice pattern. By the way, they don't use JEE, they don't use JPA, that's directly Hibernate because of the performance, and because of this thing. This nice thing allowed them to do such tricks. It's really nice thing. So take orders, let's skip it, just normal SQL code. As you see, a lot of magic with strings, selects, even though they use name queries is at the end a string somewhere, and some annotations. So they did some Hibernate config, MySQL configs, and things like that. You will see in the code, generally, if you look. So after 1 day of coding on both universes, yeah, come the reality. They started into the production. And by the way, we can simulate what was the production with a simple, I wrote in a simple simulator, so you can check it on your own because there is a Galaxy simulation cluster that simply does the things. Simulates customer, like 4 threads, constantly doing some random place order, thread for the pizza boy that's doing constantly take best orders, and 2 threads for owners that constantly look how many things are there in the queue. So why 7? Because this simulation is designed to be working well with 8 cores processors. Simple like that. It's not, by the way, I really spent a lot of time to make this simulation and benchmark quite good. It's not that easy to do good micro benchmark. There are a lot of pitfalls, but I think I used a lot of my experience. If you find there any problem or whatever, just tell me. Maybe we'll resolve it. But this was the simulation. And of course the real life. So there is some code like making the JVM warmed, yeah, then really processing something. Okay. What happened? Let's go about in the real Galaxy. What happened? Processed order. How it would work. Do you have some clues? What was faster? How much faster? Okay. So in the normal universe, world of Java, they achieved 40,000 pizzas per second. For a typical system, of course there was, in this measure, there is no, for instance, HTTP calls or something like that. It's just plain Java. Nevertheless, it's quite interesting number. So in the other universe, they got something like 600. By the way, it was on already tuned MySQL with some tricks. So it was not the first number they have seen. Nevertheless, that was so that's how I would say writes. So these processing orders work on both universes. You see the difference. Does it make a difference for you? Yeah, I think it's quite visible. And so in the first case, of course, the owner was happy. It's 4 times better as he wanted. In the second case, yeah, you see, he wasn't that. So no free beer, no pizza, just punishment. And remember, aliens do not have human rights. So this peeping spell, observing, if we only read, you know what was the result? I really spent a lot of time to prove it's not fake. It's not some kind of artifact from JVM. It's not, because this really, so many times you can read along, because really there is nothing more there. It's like almost empty code, almost empty. So then, in this other universe, of course, it was 6,000. It was, so reading, as you see, is way faster than writing, of course. But in this universe, it's like million times faster. In the second, okay, million not, but really 100 times and 1,000 faster. In the second, it's like 10,000 faster than normal writes. But at the end, difference between reading here and here is like incredible. Nevertheless, as you see, here was really happy. And no, that's not what I wanted. So, in a normal universe, they started their production on this laptop. I stolen them from this laptop from them. It's okay, because it was enough. It was absolutely enough. Another universe, they were looking for some server rooms, whatever, to make it somehow working, but they had this problem with the one database, MySQL, whatever they did, it wasn't really performing well. So in a normal universe, they even went farther, okay, maybe to the other universe. They tried to tune it a little bit. They hired MySQL consultant. In fact, in this world, the best MySQL consultant is a simple script that you can run that tells you what you have wrong. The research script really helps, and then you can read that book that helps you to identify further problems. At the end, there were only 2 tables. So it's not that horrible to find out that finally they found some ways to make it perform better in this other universe with MySQL, mostly with tuning MySQL, caches, buffers, and things like that. In normal world, by the way, they also profile Java, by the way, in other universe also. And they found out they had a bug in performance. It could have been faster. So after, let's say, 1 day of struggling with the performance in both cases, with one just because they drank a beer as a gift, so they wanted to see. They achieved this in the normal universe, 60,000 per second. So the code on GitHub, in fact, the last version, it performs like that. And it wasn't a big problem because those was Java profiling, really easy. In other case, they almost made it to the 1,000 per second on this laptop, but it was close. It was not really, but it was close. So let's see, let's pretend it was 1,000 processes. As you see, in this other universe, still the owner wasn't happy. It was not that what he needed. And in the first universe, he wasn't also happy because they told him, it was working, why do you try to spoil the thing that is already working? Don't make it better. It's good enough. But okay, that's the lesson. Never do this beyond if you are not asked. So after a few days of operations, let's now go to the do I have a counter somewhere? How much time do I have? Okay. After a few days of operation, what happened? Power cut! Power cut! And you know, these guys from the other universe said, oh, everything we have in MySQL is reliable, everything will be fine. But the guys from the normal universe, besides this one experience, were just shocked. What now? Do we really believe? I have 5 minutes. Oh, that's bad. So what has happened? They seen this picture in this normal universe, and after that they see this picture, and then they said, "Oh, thanks God, we have this all on the notebook. So this has hibernation, so memory is preserved, no problem." Works. As you see, sometimes the simple solutions are okay. So, but after a couple of days, the next problem came. The owner said that he doesn't trust the pizza boy, so he wants to know to which planets he delivers pizza. The guys from other universe said, okay, they will never delete orders again. They will mark them as deleted, or even create some other table with deleted orders. Can be done like this. And these guys from a normal universe, they said, okay, we'll change our take orders procedure to store somewhere what was processed. By the way, they said, okay, that's data that's not really important for us, for the application. It's only for the report, for the owner. It's not really operational data, what was processed. It's some kind of report. And you know what can you do with not important data for application? You can store it in database. So they decided to, by the way, in this method processing that, store it in some kind of SQL database. So, and then they restarted the system. And all this lambda were processed. And by the way, in this normal universe, it means from the start of the system, it was happening exactly the same as was normally happening, but besides the orders, the things that were stored, preserved in some kind of table in some other database. So what happened? Both teams realized, and the owner says, so I know this, I want this data for yesterday. And you know, in this other universe, they say, sorry, till yesterday we are deleting everything. In the normal universe, they have this log of the events from the start of the system. So simply after restarting, it was there. Nothing was really deleted, never, because they have this event log. So another real world case, let's skip, like making complicated pizza. What if, so for instance, customer can design pizza like half of then if you do it with a tables, you would see like, I don't know, something with 20 SQL tables or whatever. It would be horrible. So maybe they need a text field to store, I need a pizza where on the half there are mushrooms, whatever. If you do it with a Java, you can use, I don't know, builder, pattern, whatever. You have a lot of possibilities, everything that goes in a Java, like doing abstract syntax tree of defining your pizza goes and will be preserved. So it's very flexible. So the difference at the end. Difference is like that. One normal universe is very fast, the other universe is terribly slow in comparison, even though it's way faster than the typical systems you work with. In the normal universe, you had most of the code in Java. In other universe, it was string annotation. By the way, yesterday I realized how can we call it. In the normal universe, we have strongly typed system. In other is stringly typed. So everything is strings. These SQLs in the annotation. This one normal universe was very flexible, the other was limited. The one was very testable because you can easily test Java objects. It's really easy. In other, it's testing, for instance, either you use some kind of mocking. Mocking the database is a really horrible idea because at the end with HAPA, what do you test then? You test nothing if you mock. So you have to use database and it makes tests really not that easy. And there is one other difference. In this normal universe, they used sophisticated Java structures like priority queue, for instance, that you don't know because you are not from the normal universe. And the other universe, they had Java that was doing generally nothing. Can we call those alien developers really Java developers? I'm not sure. But why those universes were different? Long time ago, you know what that is? That's memory. The last memory that you can see every bit on your eye. Really, from 60s. And there was a sweet spot now around 90s if Ball Galaxies that computers had mostly one CPU core and memory was expensive, but something like 100 megabyte was available, but disks were huge at that time, 2 gigabytes or 20. So it was perfect time for something called JE or some object relational mapping. We can process information of disk because we need something like 2 gigabytes, but in order to make it simple, let's pretend it all's done in a RAM. So we have this object relational mapping with databases. That was really sweet spot for golden era of databases. They really made sense at that time. Around galactic year 2003, what happened? In a normal universe, RAM became relatively cheap, more and more with every year. And computers had multiple cores, and you could use that power in applications. So they realized they have so huge amounts of RAM that they don't need databases anymore to process this data. Yeah. And because everything fits in RAM, so if they only preserve the events, it's everything fine. Yeah, on the other universe, RAM was cheap and huge. Computers had multiple cores, and nobody realized. That is like that. They were doing like the fathers because, you know, that's called cargo cult. Nobody really thinks, oh, my fathers were doing like this, it must be okay. So other universe, by the way, it's a very good place for database vendors, they are happy. Application servers vendors are happy. Power plants are very happy because hey, they have to provide power for all these servers. So hardware vendors are happy, of course. These guys selling this stuff are happy. Business complains like this domino, but still has to pay. And developers, you know, they have a lot of more work to do, so they are happy. It's why to change it? But then I see these problems like you have on the picture, yeah? Like somehow they are not satisfied with Java. Okay, there are of course problems also, some kind of problems that you have, maybe you encounter with object relational mappings, you have also with this prevalent normal universe. It happens. So I won't go to the details, but there are some similarities. So if you struggle sometimes with object relational mapping, similar problems will appear in this, also in this normal universe. Besides, all will be way faster. And if you look at the code of the typical system, this code of the object relational mapping world and with database and the normal would be for a long time similar, the same amount of code. And in one moment, because of performance things, the other universe becomes complicated because they have to fight with problems with object relational mapping, performance, etc. And the normal universe doesn't have to fight with that. And then it makes really a huge difference on the amount of code that you have to maintain. Okay, if you want to jump to the normal universe because you are not there, you are not a Java developer, in fact, there are some simple ways to start. Something very, very old story. It's called Previler library for this persistence. So this easy persistence, it's called Previler. There is a web page, you can read about it. AeroMem, that's my thing. It's simply the Previler, but with wrapper for Java 8 that you can use easily this lambda expression. But it's really nothing more. It's very short library. So Previler is very easy. You can write it on your own. So the third solution is use this and implement it on your own. That's the best idea. Because then you will understand how it works. It's very easy. It's like 1,000 lines of code. It's not that much in comparison to what you do typically, and you have the same. But if you are lazy, you can use something ready. So I will skip it. Everything you will see it on GitHub, how it works. By the way, I told you you can do it easily with lambda expressions. Don't do it with lambda expressions. You should generally write full classes here, like execute and query, and instead of a small lambda elegant, please use the whole class. That's because of some limitations of Java serialization, because this is perfect for prototyping, showing something that works. This is safe for productive use for years. That's the difference. So you can, of course, make some shortcuts to show, but then if you go to production, switch all the lambdas to this. Just, there is a reason for that. Concurrency and everything is okay. By the way, it's not really a problem that you have one thing at a time. Still, as I've shown you, it's more faster than concurrent thing on the databases. Because, yeah, it's so fast to do operation in memory. Queries are executed concurrently with write, so it means you need things like this atomic long if you share something with read and write operations. By the way, at the end, the data is stored on the disk like this. Journal means some events, and by the way, it's not like one event here, like one second event here. No, it's like, I don't know, 10 events here, then 100 events here, then 100 events here, and then it's a snapshot. Snapshot is if I am doing it every day, and then you restart it after a year, maybe replaying all these events from this log would be horribly slow. So we can make a shortcut. Let's make sometimes, like maybe every night, a snapshot. So let's save all this system, maybe 20 gigabytes to disk. That's our snapshot. It means next time the system is restarted, start from the snapshot, recent snapshot, and then events. So mostly it's used in some kind of failures. Problems, by the way, you think you need incredible amount of RAM to do it, because your system exists in one moment in RAM. 5 terabytes you can order. It works even with Java, so no problem. And 5 terabytes is a huge amount of RAM, a huge amount of data. So skip it. Transactions you have better than in databases. By the way, you have to learn synchronization and concurrency, so more complicated Java. And it's still, even if you don't do systems like that, it still makes sense to learn it, because it's quite interesting. You will be better developer if you learn it. Okay, replication is easy with that. If you think I need some kind of indices, there is even so you don't. Priority queue was a special index I really implemented here, but there are some ready structures. So hash map that you can, for instance, you sort faster using this column or whatever. There is special project called CQ Engine. You can use that. So it's like making fast query in memory with Java data, with Java structures like lists or hash maps. Yeah. By the way, who has heard about CQRS? So what I've shown here is, I would call it poor man's CQRS. CQRS is the full enterprise version of this approach, like event sourcing and yeah. So this is, but if you read about CQRS, that's great technology. I would say very safe on production. There are lots of systems with that, but the learning curve is steep. It's really not that easy to make a first move, the first system. So this is easy CQRS for you. You can start with that, and then if your system becomes really huge, you can switch to the CQRS that you can read about a little bit more. But you will be familiar with the problems, how to design a system. Yeah. So advice from me, always if you do systems like that, they are so fast that remember to put thread sleep often, because if user saves something and immediately responds, then they think it's fake, it wasn't saved. So that's my solution. If then somebody says it's too slow, then you can easily fix that. By the way, what's the difference between this and isn't this simply a database? There is a huge difference. What is the source of truth? In database, you store the state. You model it, and this is a state in table. If it's MongoDB, SQLDB, whatever, that's the state that you preserve. In this system, the state is only temporary thing in memory. You preserve events, and that makes a huge difference. That's the philosophical change of thinking, that you need to learn that. By the way, there are some enterprise alternatives. New framework, I recommend it, Lagom from TypeSafe. That's Lagom, that's for Java. It uses CQRS approach. It's very, very funny to try it. It's really an enterprise-ready product. So, and it's open. Also, I don't know it's open source. Surely it's free to use. I think it's open source. Akka persistence is the same approach for Scala for Akka. You can also use it with Java. And CQRS generally, the best guide describing is Greg Young. I recommend his talks. But this is the how to make it enterprisey. This what I've shown is great for startups. Until you grow, this system isn't somehow limited. But I would say it doesn't have everything ready. Like replication you have to do on your own. So maybe in one moment you may switch to this solution if you see that you need something more enterprisey. But okay. So the end, try it first on something small. You can be incredible efficient, you can do incredible system, but start on something small because this completely other way of thinking. And if you do it from the start on some kind of new important project in your company, you may fail because you are not ready for this other way of thinking. I don't know. My first system were not really good designed. I needed one or two systems to really find out how it works. It's generally with CQRS because it's other way of thinking, and I think that's all. So just drop magic, forget, make Java normally. That's my message to you. So are there any questions? Or do we have no time more? Okay, questions? You can of course ask me later because I can talk you more and more about this. Yeah, so some stories from the real life. By the way, there are great big companies doing that. So for instance, the LMAX exchange, you maybe thought, of course, it's not using my Aero provider, but they generally process data in memory and use these databases only for storing things like for reports. And they have a heap like 40 gigabytes and with really hot data. Yeah, so, and there are more systems doing that. Like, so really memory and preserve events, and do it very quickly, incredibly quickly. Yeah. Okay, so thank you.
Hello, my name is Ilya and I come from Novi Sad. This talk is about our approach to agile development. And to put the story in context, well, I have to do that because agile is so many things to so many different people. So, you know, if you don't put it into a context, then some of these ideas don't make sense or just look stupid. So we have been developing Active Collab, a project collaboration platform, for a decade now, so almost a decade as a commercial product, a decade as an open source product, since open source version. And we are in process of starting our own software consultancy as a sister company. So that's one of our strategic projects. To put things into context, Active Collab is a software as a service type of product that also has an on-premise version. So we have a self-hosting version. This means that we have real releases, like version numbers, so it's not continuous integration. It's a hybrid because you cannot have continuous integration when you have on-premise version. You have to deliver particular increments and you have to persuade people to actually upgrade. So every new release has to have value and communicated value for them to upgrade. So that influences some of our thinking about how we develop features and how we develop services. And software consultancy is a strategic project for us because Active Collab is used by consultancies a lot. And if you are if you've been developing a product as a software company for a decade, you kind of lose touch with challenges that consultancies face. So technically we are putting ourselves into like consultancy fire in order, it's connected with Active Collab as a product. It will eventually, experience that we gain from consultancy will translate to Active Collab, and experience that we have with developing Active Collab for 10 years can easily be translated to consultancy, so they go hand in hand. Plus they should make money, so yeah. Sometimes we sprint. That's the this is like typical Scrum, like first or second graph from when you Google Scrum graph. And we do it not necessarily by the book, but a lot of elements are there. So we have daily sit-downs because they don't last long because they are time limited most of the time. Team leads have a bit longer meeting because it's like 15 minutes for the team to stay to answer the 3 questions. And then if anyone has a particular question for the team lead, they have that. I give them an hour and then they are off. A colleague usually gives them more, but I give them an hour. So 15 minutes for the meeting, 45 minutes if they have any questions, and then as a business owner, I'm off. That's my lead hat's off, and I'm doing something else. 2-week sprints. Each starts with a kickoff. Each has a goal or a theme, and definition of done. We recently changed it to it has to work in staging. So it's not like quality assured. It has to actually work in staging environment, because we found that integration is challenging. It's a moving target. If you like develop different elements, then integration adds a lot of complexity at the end if you just hope that it will work. So we agreed that deployment in staging and quality assurance in staging is definition of done when we consider a feature or a functionality to be completed. This is Shepherd, is our current project that we are working on. By big project, well, you guys are some of you are from enterprise type of software and bigger software. Big project for us is like 6 months, so that's why we can do also sorts of stupid things and still be agile, because our projects are inherent by their nature. They are small. We make them small. So our big project is like 6 months, and here are the sprints. This project illustrates type of project that is deadline oriented. So how you estimate projects? You can do 2 types of goals. First, you can shoot for a particular date or time period, like second quarter of 2017, and then you use that date, and then break down the project backwards. So you break it so things that you want to implement fit into that time frame. You lose a lot of extra functionality in order to meet that date. So you are moving backward in order to make the deadline. Another type of projects that we do, sometimes we do this, sometimes this one is deadline oriented because we have window of opportunity for 2 weeks around Christmas. That is when deployment of this thing, this one is our billing, and it does billing, it does licensing, it does like account management. So it's a core of our infrastructure, and when we deploy it, it will disrupt a couple of things, and we want to affect as little as the smallest group of users as possible. And so it's like end of December, like Christmas, when they are with their families, and so that is what we are looking for. If we miss that deadline, then we have January, which has like sarma, paprike, our Christmas, everyone is connecting the holidays, and then January is like, no, and it's February, and then if it's February, well, we waited so long, so it's March, and it's December. So yeah, like make it work until December. Another way of doing things is like you are shooting for a quality level, and then you implement features and elements of functionality to reach that quality level. So the deadline is moving. It's the quality that's constant. It's quality that's agreed by the team, and unless that quality has been reached, functionality will not be released. So different types of looking at how to estimate work. This one is deadline based. And this is for projects that or microservices or services in our infrastructure that are more than a month or two. Release date is a month or two ahead. So if it's more than a month or two, we will sprint it. There is no way to use the different method. There is, but it does not work that well. And this is for biggish type of projects. So when functionality, you just cannot plan it that far ahead. It's just too much work to plan it, and plans change, and then you have to change, adapt, and it just keeps moving. On the other hand, Active Collab is a stable product. It has been around for a decade, so we pretty much know what we are doing. We know which elements make a good project collaboration platform. We know what our customers are asking, who are customers, who are they, what they do, what are their challenges, and our customer care team keeps track of their suggestions. So they have like big features, and then whenever a suggestion comes in, like from chat or from email or from phone conversation, software presentation, they will map it with the features that we already have, or in some cases the idea is so novel that we haven't heard of it yet, and then they add it. That's rare. In 10 years you've pretty much heard everything. So and we actually do listen to customers. So these are our actual numbers. I don't know when exactly was this screenshot taken. This is like from Google Docs. So task dependency is pretty, well, not necessarily complicated, but it affects user experience a lot because it adds friction, it adds constraints to the software, so you need to address constraints. We like gray out, like complete checkbox when predecessor is not completed, yada yada. So you need to like really get the user experience right. You need to plan it well, design it well, because it will affect the entire software. On the other hand, like ordering of tasks on my work page, that's a low hanging fruit. Quite a bit of requests, like this is weekly or monthly, I'm not sure. Quite a bit of requests for something that can be like implemented in 2 weeks, like designed and implemented. So it's a long hanging fruit. Free plan, business, tremendous business impact, infrastructure needs to be planned. That's why it's red. Custom branding, of course. Do you want to let them custom brand your software, or what's more valuable, to take them money so they can white label it, or to have your brand always in front of the customer? So that's not a light decision to make. So you have to be careful with that. But everything is recorded. we recently published an article in Smashing Magazine, and we said like we listen, we always listen, and we record all the feedback. No feedback gets lost, and our friend like bullshit. Of course, that feedback is lost. Like, what kind of company are you? You are actually listening? Well, yeah, they are recording everything, and it makes this, and we make decision based on this. Is this a design by committee type of thing? No, we choose the way we will build these things. We just want to see how their requests score. So when we know what we want to build, for example, like my task order, we will put this through this process. So this is like, we call this feature teams. It completely, the process is like mix of everything and nothing. It's a colleague suggested one thing, we suggested another thing, then we discussed this and we agree that it will not work and this will work and this will not work and this is great idea and this is stupid idea, and then eventually we got to this this process, and it does change. So this is graph for like 3 months ago. It's changed a bit already. So the whole idea now we know what we want to build. We discuss it with the designer, get all the edge cases ironed out, all that we can anticipate early on, get the copyright, because words are the most important interface element, well, most important interface element, period. So it's not buttons, it's not inputs, it's not radios, it's not graphs, it's words. How you communicate what something will do or what not do. So if it's defensive design, so you are why something failed, etc. So we try to get the copyright. We try to get the flows right, and we try to get the user experience as good as possible at this phase. And it's usually like 80-90% done, like design-wise, before we kick off a new feature. Once we kick off a feature, its first day is all meetings, pretty much. 3 phases: product owner and or project manager introduce the feature to the development team. So they communicate what this will do and why we are building this. So it's important not just to know what you are building and how to build it. It's why you will build it. Nice thing about our software is that we use it. So everyone on the team have experience with like task management, even doing projects for clients. So they have great input in this phase. So we discuss like why, like bigger picture, why are we building this? Sometimes it's obvious, sometimes we find some interesting use cases, and then team goes to your room. They go to their room because they get a war room for the feature, and then they discuss implementation details. So how they will approach development of this particular feature. Break it down into tasks, then break each task into subtasks. Level of like, this is estimation work, so it's part of planning and estimation. So the level of detail that they go to is like, we need this and this route that will handle post request to this controller. So it's pretty detailed. It's not like programming in Active Collab, but it lists like structure elements of the software that will be built. Once you have that list, you know how much time it will take approximately to get that developed. We use t-shirt sizes for complexities. We call them complexities, and I'm not sure how it's called in Scrum. Story points. We call them complexity points. So S or small, it's I can do this in a day. It will be done in a day. I can probably do a couple of these in a day. So it's smaller than day. Medium is it will take a day, maybe a bit of tomorrow. Large is this will take like 2-3 days, maybe a week. Extra large means break it into smaller parts. So we don't have extra large, never. Like epics are projects. Break them into sprints, break them into features. Get them to S, M, and L sizes if possible. in our cases, in our environment, that is possible. I bet that there are projects where this cannot be used, but in our cases, we can really break down tasks to a really small level, like up to a week of work. Once they have the tasks, they know their velocity based on the team, and then they know how much time approximately they will take. Sometimes earlier they would just say like 4 weeks, and then it takes them 8. Now we would just sum up the complexities. We know our velocity, and we will just do the math and see how many weeks they need to complete the feature. If it's like 6 weeks, we are okay. If it's more, then we should break that feature into smaller ones. Haven't had that yet, but that would be like a rule of thumb. Another thing that the team proposes at this point are demo days, when they will demo a particular bit of functionality, because we learned that integration, again, repeating integration. Usually it's like 20% for bugs and defects, and 30% for underestimation, and you are like 1.5 modifier for your initial estimate. And somehow nobody like calculates integration into the math. Is it a defect, or So we add integration as early on. We start integrating software as soon as possible, and start working on features like to have them do something as soon as possible. So demos are once a week. Usually it's like Thursday is let's make it Thursday, and then it's Friday. So it's always like that. And then team demonstrates a bit of functionality. It has to work. Even if it's like a command line that takes one argument to do all sorts of things, and then just outputs done. At least it works. Show me in the database that it actually updated the roofs or migrated the data or whatever. It does not need to be like user interface. It can be like, just make sure that it works. One thing has to work, and it's like a week of work. Another important element here is like, since features are always quality estimated, so they are never deadline estimated. I don't care if it's like ActiveCollab sells well. So there is no rush to do any particular feature by any particular date in our case. What does comes to bite us is if we rush it, if the quality is not there. So we always estimate and shoot for the quality level. So demo days help us see the feature prior as it evolves and see some early problems. So we will fix things during development instead of having to fix them later. Because when we get to the point like shipped something, it needs to be improved or fixed, it competes with this, and it will never get a priority unless it's a bug. It will, like if it's like small improvement, like 2 days of work, it competes with other features, and it just like we could have do it like we are in the middle of recurring tasks feature, and there is one flow that we noticed did not work well, and we said, okay, we will launch without it. We are like 3 weeks late with the estimate. That was like 6 months ago. 6 months ago, 2-day extra work never got done. Like that flow that we know, it's not broken, it just can be much better. That particular flow did not get to the priority list, and I doubt that it will take a year probably before someone addresses it. So we will find these problems, and then we will, while everyone knows what they are doing, and while everyone's in the code and understand every bit, we will fix these usability issues. Like okay, so we have like high quality standard, now just make it better. Make sure that it works from the day one. A different feature that we developed like 2 months ago, not a single bug report, not a single feature enhancement request for that particular. These are like set of reports. Not a single one, just no defect, no rework, no nothing. It's just there, people use it, we watch the data, people do use these reports. And tweet, they are amazing, like these are some timelines, and people like timelines. And no rework. No 0 bucks for rework so far, and they are making us money. So getting the quality right proves when you are working on features in stable projects, in stable products, actually makes money and saves money. So we focus there. Beating the deadline probably would have a different result. We would have a rework, so we would like work that we do ahead, we would have to work, invest it later on if we get to it. One of the changes that we made compared to this graph is that we make sure that quality assurance is part of the process from the day one. So front-end developers will create mocks, and so quality assurance team can create like front-end tests up front that are broken. So and quality assurance is done with every demo. Every demo gets tests. Tests get implemented, so code that will satisfy these tests gets implemented, feature gets implemented, and what this helps us is like we get more tests this way. So strange thing, because it's always like we have developed this, let's bring it to the customers, rush the QA to complete the task, and then when he completes, he will just click through, confirm that it works, and it just goes to the customer. This way, tests get written as software is developed, and we end up with more tests. Like for demos, it will be like 8 tests probably. With QA done later, it will be like probably just 3 tests. Quality assurance done late usually takes a lot of time. So in some cases, the feature went and has been stuck in QA for like 2 weeks, 3 weeks with no particular reason. It's just a bunch of work has already been done, and now somebody is testing the functionality. Things don't work as expected. We notice some problems, and then rework, and then 3 weeks for a feature that was like 3 weeks in development or 4. This way we have like a week of quality assurance, code review, and in that time development team works on bugs. So that's the, we don't switch them to a new feature. We don't switch them to any other work. This is like exclusively one thing that they are working on. So we will not switch them to anything. If they submitted a feature that's buggy, they will fix bugs more. So it will be like 2 or 3 weeks of quality assurance and code reviews and them fixing bugs. Or if they submitted a stable feature, QA will be done and helped QA to get the tests done and everything. It will be out in 3 days, and they will have their sabbatical. They will have their day off. So that's the whole point of 2 points. First, it's not like it's punishment. It's not punishment. If something's buggy, just don't switch context. Do some small things, improve stability of the product, improve performance. Just don't start something big. And on the other hand, no context switching. Once merged to the master and deployed to customers, team gets a day off. They can do whatever they want, and the next day they get a new assignment. That's pretty much the process. So a couple of lean, like this is this crummy? No, is this? This is actually something that we really thought of. A couple of people contributed different ideas. We put them in a pot and ended up with this. Gave it to the designer to make it pretty. Couple of lean things, like lean thinking, like Toyota Production System, like that mindset are like strict work in progress capacity, like. Team is committed to one feature and one feature only. They don't do anything else. They are just doing that particular thing. We don't pull them to any other projects. They are silver bullet, like things like production is broken. Something's broken, like fix it, and that type of thing, like production jeopardizing defects if discovered, and we have not had that yet. So this is like you are working on one thing and one thing only until it is done. Then you have a day off, and then you are off to the next thing that you should be working on. So strict capacity control, high quality, so quality oriented, not deadline oriented, completely quality oriented. Minimize defects, minimize rework, and what else? I forgot. There is something else. And then we submitted this process and wrote an article for Smashing Magazine, and then guy said, DC Dave something, congratulations, you just invented waterfall. And it was like, oh, fuck. So he got me thinking, yeah. And it's been a couple of months, so I have time to think about it, and I think it's bullshit. Sorry, streaming. Active Collab is we are solving a known problem for known customers in a known environment, and we can plan. We can plan some ideas and some features, like they are brewing in our heads with our designers for 6 months. It's not like they are doing their work for 6 months, like designing that particular thing and then end up with a book, like implement this. It's just we give it time, and then when it's well thought out, we implement it. So there is quite a bit of planning ahead, but not in a traditional way. We are not sending men to the moon. We don't need that type of waterfall development process. Yeah, so Dave Eisenhower, Dwight. And it actually helps, like planning really helps get more quality features out. What happens when people work on big things? They don't work on small things. So and defects just pile up. So they are no matter how much, like Active Collab is like 1200 unit tests plus like 200 API tests, and now there is like 30 something front-end happy flow tests and growing. So even with these testing, and these are like every push triggers the suit, and these tests get executed. We know what's green, what's red. Even with this in place, there are still some defects, and they just pile up. These are like, when I'm on a Hungarian keyboard and I press Shift 2, it does not trigger @mention feature because Shift 2 is not @mention or something like that on Hungarian keyboard. So, okay, now go install Hungarian keyboard, see what happens, see how you do that, and why doesn't like monkey sign trigger @mention in this particular keyboard layout, because its code is different, and so these are this type of defects. Okay, Hungarian, but this is Spanish keyboard had that problem. So, and there is like when I'm in Denmark and do some things, then other thing does not work. These are really small defects, but they pile up, and then you have like mental energy just to go through the defect list, like 60, 70 of these small ones, some bigger, some smaller. In order to address them, we organize like bug hunt. Like last one was 2 weeks. It was a mistake. Just see like energy, tank. Second week is just dropped completely, like a bug a day per developer, and they fixed like 6 a day last week. So 2 weeks of fixing bugs, not good. Not keep it short, like 4 days, and extra day for leftovers. And yeah, the whole point about comparing the two things, like Scrum, like sprinting through work, sprinting through backlog, and using something that we developed by putting together elements from different methodologies, is just to illustrate that there is no one-size-fits-all methodology. It's always thinking. The most important part of both methodologies is retrospective meeting. So what did we do good? Where we messed up? What can we learn from this? So with this, putting quality assurance at the end of the cycle, not a good idea. So we, after 1 or 2 features developed like that, okay, now this is a repeating team. Move it alongside development. And yeah, think about it. So Scrum is great. I have a love-hate relationship with Scrum because we did not have projects that required Scrum. Now that we do, it's awesome. Just and it's prescribed. You just try it, and you can use something off the shelf, and it will work most of the time. For the things that it does not work well for, you just think and improve in your environment. So great starting point. And different approaches get different results in different environments, different contexts, and serve different purposes. You just think about them, just don't apply something that's written in a book. Thank you, you rock. Okay, questions now or later, and these are Twitter accounts that this is maintained by ActiveCollab is maintained by our marketing team, but they surface a lot of useful resources if you are in like consulting and productivity and stuff like that. And this is my babbling downstairs. Yeah, and my partner and my project manager requested that I tell that we are hiring. So am I like 67th person on this conference that said that we are hiring? So go to careers, backend developers, front-end developers. I don't know. So. My employer told me to tell them. Okay. So any questions about, I don't know, products, processes, making money of software by yourself, for your employer? Okay.
How many teams do you have?
Current. No. We used to have like two teams. Like we are 20-something operation at this point, and don't get me started on the head count. So less head means more profit, which means better business, which means you can invest more money in marketing, which means you can bring more business, which means that you can bring more people. So we are kind of like oscillating, like yo-yo. Lot of people, small team. Lot of people, small team. So yeah, we had like two teams. Now we are pretty much on one big team to get to get the Shepherd out. So everyone's in one room and just hammering that thing to get it out in December. But usually it's two teams. Dependencies, no strict dependencies. Like really. Well, promiscuous merging, like merge, if there is something like merge their branch and integrate it locally, see how it works, and then continue. There is like one like date refactoring that like 6 months in front-end layer, so someone did not use Moment when they should have used Moment, so it's like 6 months of work now, and that one's hard. So we have been merging that particular branch in our feature branches to just see if there are conflicts and fix things up. And so, but yeah, I doubt we will take any projects where we will have that much collision. Projects that we tend to work on are smaller in scale, so that's good for us.
Yeah, you mentioned several times quality-driven planning versus deadline-driven.
Yep. This is internal project. So the Shepherd is internal project. Our employees will have to manage for a week or 2 or 3 or 5 or 15 until we get that report that they asked for. So this one, user facing. So what Shepherd does? It's a single sign-on system, and it's a licensing management system. So you come to our site, leave us some money, we give you a license, you download software. That's all done through Shepherd. So it processes cards, PayPal, it issues licenses, sends you renewal, reminds you that you should renew, reminds you that your card has expired, like that type of. We did not find a solution that we can just use. So we developed our own, and it has like client-facing part of the system that's like completely quality-driven. That cannot be messed up. And there is a back office application that has all sorts of business metrics, like what is your monthly recurring revenue, what is your average revenue per user, business metrics, business intelligence, reporting, some licensing management, transfer this license to another user or whatever. That does not have to be to the standards that we put for client-facing pages. So just that can wait. That's the type of work that can wait. Plus, if you are like deadline oriented, you see which are the things that you cannot compromise on. Client-facing pages, no compromise. Data migration and packing of all the business intelligence data, not a compromise. Business intelligence data is really important. Backup, account lifecycle, not a compromise. Discounting functionality, compromise, that can come later. We will add discounts later on. So you just make decisions and then make sure that you fit in the given time frame. That's it. Okay, thank you very much. Yeah.
a YouTube app, a Twitter app, a Facebook app, and a weather app. The interesting thing is that this is not any kind of Android TV device. This is not any kind of Apple TV device. So it is a pure set-top box going to IPTV or OTT systems or things like that with the Linux operating system underneath it. And this is also an HTML5 power device, and these apps you are seeing, this is something that should be in my presentation, are basically web apps using JavaScript to power it. So we did something different in Telekom Srpska or Amtel in Bosnia and Herzegovina. We did implementation of these 3 widgets, and it is only implementation in the region as far as I know. I think some Bulgarian telecom has some kind of YouTube, and we are doing this. Perhaps has any one of you hear about YouTube/TV or YouTube lean back? 1, 2, 3 hands. So yeah, I'm here. Okay, great. So still no VGA. Okay. Kad počnemo od početka? Kad stigne kabel. Okay, we are waiting for the cable. We will be a little bit late, but I can only for you guys that are here. And the unfortunate thing is that I send the links to many of our friends, to many of our partners from abroad and here, and they are probably waiting about the live stream, but what's there is there. So I can show you how these apps work in meantime while we're waiting, and I hope I will not repeat myself again at the end of the presentation. Okay, this is a YouTube app, and the things we are using is iframe API to trigger video playback, and on the other hand we are using Google's YouTube data version 3 API for fetching anything you want to know from the YouTube. So this is list of most popular videos from Serbia. Those are from Serbia. We'll probably laugh because everything is folk. And yeah, and for the guys who are not from Serbia, perhaps they visit Splavovi and things like that, so perhaps they know any of these songs. But never mind, you can press OK. It will fetch the YouTube data for the first time. This will take a little bit while. And if everything is okay, and I hope it is, with the play button, this is my input device, I don't use the mouse anymore, you will be able to see a YouTube video. So there are some optimizations for viewing on TV. You can set up a full screen, of course, go back from the full screen. You can go on autoplay, and for example in upper right corner you see the next video that is scheduled by the playlist. You press that button and it will automatically go to the next video. So you can gather your friends, put up the music on a YouTube and let it autoplay, and it will go on and on and on. So I wanted to show you how someone can log in, and I think maybe I can use this kind of a device. As you probably know, the problem with the remote controller is the way of input, and you cannot use text boxes as you would use it on mobile phones and computers. This is why we have implemented something that is a new trend. It's called the device login. You press login button, you get some kind of code. I hope I will get some kind of code. Please wait, please wait, please wait. Please wait, please wait, please wait. I was hoping that at least the demo would work as it's supposed to be. Yeah, this will probably do for hour. Okay, for some reason we have a bug and it happens, but I can show it on a Twitter account. This is an implementation of Twitter. You will hear something more about the Twitter APIs. The Twitter APIs are really wide. You can see, you can get any information you would get using Twitter on a standard device. My credentials are all already saved in this device, and of course it logs on automatically. So for example, I can switch to the right. I have trends that are most popular in the United States right now, and Voxxed Belgrade number 16 being the first hard-coded of them, and every 3 minutes the live feed will go on. So it can be an interesting addition. For example, if you have Game of Thrones premiere in the next 10 minutes to see what are people are saying about it on Twitter, you can press info and see, for example, the image. And if I do this, I go to the main menu and I want to make a new tweet. And for example, I'm watching the Game of Thrones right now. I can switch to the transparent mode. I hope it will work. Okay, this is not a Game of Thrones, this is Big Bug Bunny. But if it is, I can do a green button to tweet what I'm watching and press OK, and it will go automatically on a Twitter page. So I am going back, seeing my home feed, and I hope there will be watching Big Bug Bunny on the Big Bug Bunny channel. So this is some kind of TV integration that you cannot achieve with the simple and with the TV apps. Does any one of you has an Android TV home or just one, two? Okay, the problem with this and the problem with the Apple TV is that it is really loosely integrated with standard TV apps, with your TV guide, with the programs, things you look with, video on demand, things like that. And by integrating and doing these apps tailor-made for the operator, you can integrate each API, each data you have, and publish it using social networks. And that this is an intention. And the third one, and the least good one, on my personal opinion, is Facebook. And this is only because Facebook always changed its policy. And right now, when you are using Facebook API, each API endpoint you use must be authorized. And this is why we have a problem, how to say with it, because you cannot see anything about your friends. You log into your Facebook account, you want to see your home feed, or what is it called right now, I don't know. And for example, Milos has shared something on a Facebook, I cannot see it with this. You can only see the posts that are directly dependent to you. And since the customer has wanted some kind of true Facebook experience or whatever can be achieved, we didn't do a Facebook as the way we should. We should just use it to fetch some data and grab it on the internet. So right now you can only see your wall, make some kind of a status in the same way you did with the Twitter, or see your photos. I hope I don't have some photos that are inappropriate, so you can comment them, watch them, things like that. The things we could also do is some kind of upload, but we didn't consider this because of copyrights, and it would be impossible to use this kind of input for the copyrights. So as we are still waiting, this was some kind of small demo about all the functionalities you have in these three widgets. My intention was to speak about how these APIs are used, how can you use it, not just on the TV apps, but also on any site you want. So I have technical issues, and I hope this will be triggered soon. And of course there's the weather. I hope it will work because we have some problem with the free APIs we are using. Yeah, here it is. And it will render an image. As you can see, set-top box is a little bit slow, so sometimes you need to preload some things, but this is just a demo. It is a little bit different than the one implemented in MTEL, so there are still some rendering problems, and we can see that it is 25 degrees of Celsius today in Belgrade, and it is sunny, and we can see how it will be in the next days. And I can switch to the right to the Android style to switch to Banja Luka, which is my home city, and I will be traveling. I hope tomorrow, if something doesn't fall off the roof and kill me with all of these things happening. So we are still waiting for the cable. We are still waiting for the update. Yes? Maybe that is the best way to do it. Sorry, just 1 minute. Idemo što izbjegavati. The bad thing is that I started preparing myself 45 minutes ago, and the Windows is still going on. This is some sign from the God that I need to switch to the Apple, perhaps. So do you have some kind intermediate questions? I think that this is the first time. For example, when this will be available in Serbia, I think, yeah, some of the guys that came to our stand asked me what is with Serbia. Telecom Serbia is, for example, in the process of getting the keys and approval for their set-top box devices for YouTube, but it's still ongoing, so I really cannot give an answer to that. You are switching the... Yes? Yes. Sorry, I forgot about that. This is really improvisation, so I would really like for you to, if you can see it on a big screen. This is something that was intended. Okay, this is the situation we have when we first plug in our box, came to the home, we subscribe to the operator services, we get everything for free or for the fee that we usually pay for the cable services, and we see some kind of a Facebook, YouTube or Twitter, and press OK, and we will get some kind of this screen. So I will press login, and on the screen I will see, please go to the facebook.com/device. This is the device login, so I will need to use some extra device for the input, and this will be my phone. And we were thinking about, and the Facebook and Google with their device login is always thinking about that everyone nowadays has some kind of a smartphone that you have on your premises that you could use for these kinds of things. So I will go to facebook.com/device. I don't know how good can you see it, but you can try it on your phone. You will get input box and you will just enter this code. So it's 1F6 66666 1F6 FQ 5252 C, and you will press a continue. The dialog will appear asking you whether what permissions the app has, and would you like to authorize it. I will press OK because I have already authorized it. And the callback function that listens on a server to a Facebook endpoint will trigger the fetching of data when you press OK and when it gets its token from the Facebook. This is a very good question, and some part of my presentation was intended to speak about this. Sorry, my colleague has had some pre-final version of it, so if something is, if you find some kind of syntax errors and things like that, please don't consider it as a problem. So back to the presentation. You are going to hear about some kind of introduction. I already spoke a little bit about what the TV devices are, and I will just do a very quick passing through all of it. How we did an implementation. I hope that my computer will be ready. It's on 68%, I don't know, but I really hope my computer will be ready so you can see a live demo. We did some kind of a widget that integrates everything of it. What are the challenges and limitations? The thing with the device login and things like that. And you already saw the TV box in action, and it's a live demo. So this is the duplicate slide I have. My colleague was saying that to me. So for the introduction, what are the TV apps? The idea of the TV apps is to use a big screen that will allow users to do more than just the channel browsing. So in still 90% of the time we have browsing through the channels, and that is something that perhaps especially older people are using every day. So it was maybe some 10 years ago firstly enhanced with when the IPTV show was there, and the first time you could use internet and internet protocol to connect it with your TV devices. So the first apps that came, they are the common apps: the TV guide, video on demand, reminders, teletext, quick zap for fast browsing of channels, favorite lists, recordings. Recordings are getting big nowadays. And the trending ones are those where the community is trying to make a smart TV experience, to use data and APIs for everything. So basically, everything that runs video can be used as a TV app. This is example of TV apps on Apple TV, and I will not take too much time with it. And by the TV apps development, what do we know? We have smart TVs, we have Android TV, we have Apple TV, we have set-top box operated devices, and languages they are written in are native development with C++ and Java. This is something that was used before. We have for Android TV, Java, Android APIs, things like that, and we have something that is also big right now. It's Opera APIs. It's basically HTML5 with their own JavaScript, in which you write your apps and publish them on the Opera Store. Very often we have HTML5, which is powered by vanilla JavaScript, and this is that kind of implementation. So HTML5. In the HTML5 we have thinking that each TV app is basically a web app. Nothing is different. You develop basically everything on the way you do. You use HTML for layout, you use CSS to design, you use JavaScript for programming and interaction. And the one really important thing is that everything is Ajax. Everything loads with just one HTML page, you have just one URL, and every other content you need is done by the Ajax. So RESTful design is also very important here. You have some kind of endpoints. For example, I want to fetch EPG data, the TV guide data, to see when the Game of Thrones will be. I will just call some kind of REST endpoint and get this data and put it somewhere in the HTML DOM tree. And at the end, everything runs in a browser. So the clash of the titans is how the browser market is right now. You have a Chrome or WebKit-based browsers, and you have an Opera. And software it all runs on is basically those two browsers with some kind of different changes that allow set-top box to control videos and things like that. So I have some kind of example here: Media Player Creator, Media Player Play. I have only 20 minutes, so I will try to speed this up. So this was supposed to be a video for those who saw Silicon Valley, where the bald guy always says, "Give me the box," and I present to you the box. So I was trying to make this a little bit more funny, but with all of these problems, probably it isn't. So the box, I have it here somewhere. It is connected right now. I don't know. Can you see it? It is a small factor computer with everything: CPU, GPU, RAM, and basically in 90% it is some kind of lightweight Linux distribution going on it. Very lightweight. You don't have anything. In most of producers don't use anything except the basic scripts and basic Linux that is needed to output the video. It is basically cheap, about $40 to $120, the big ones. And the companies are here also. The another difference between this and the computer is that it's intended to use HDMI, S-Videos card, USB, digital audio, and that kind of inputs. So I will not take my time with these informations also. The other thing that is really important is UI. It is a lot, as you can see here. It is some kind different than developing standard web apps. You have constant proportion. For example, this is just HD, 128 times 1000. 1280 times 720. So you have a custom proportions. The important thing is to keep it minimalistic as possible. Accent is in video content and images, so you please use the big headlines and a small amount of text. And animations are tricky questions. If you maybe noticed the first time, I did just animation here to notify customer that the operation has been successfully done. Most of these boxes are really GPU, poor when it comes to HTML5 and animations, and most of its juice is used for displaying and outputting a video. So if you don't have a really expensive, a really good box, at least nowadays in 2016, avoid the animations. And do the dark backgrounds and light content as I did on the presentation. So user experience, this is your ticket into this world, remote controller, and this is something that you always need to be very careful about. Remote controllers, nowadays we have directional. as you can see here, up, down, left and right, okay, and back keys, and try to use only those. If you need, as I mostly did here, if you need to do some more commands, you can use the color buttons, but please be sure to label it properly. And I will just, the text input is the greatest problem with it, that's why we saw the device login, and I will just do a quick browse of good examples which, how to say, respect all the things that I told about. This is a Netflix app, Netflix TV app. It comes with the Android TV. And for example, with up, down, left and right, you can do everything. You press OK, choose the video you want to watch, and that's it. This is the question I was talking about, YouTube/TV. You can do it with your own browsers. When you finish this, you will see some kind of different UI. If you want to have a different YouTube experience, you can do this also with your Chrome or Firefox. Just enter youtube.com/TV and this will appear. And most of my laptop is booting. And most of these how to say, set-top boxes that come with the higher prices are certified by YouTube to display a YouTube/TV. So we can't compete with that, but thing that we can do is to make an experience, to make personalized experience. If you just put on your set-top box a TV app that is YouTube, you can just YouTube it. But this is something that we are trying to change right now. If you look at the program guide, this is just a dummy program, right? But for example, if here is Silicon Valley that premieres tomorrow, and you heard about it but you don't know what it is, we are right now preparing how to say, small kind of plugin that would be enable you, when you go to the information about this program, to press down and have trailers and other data that is connected with that program. So that is the main advantage of making this kind of customized apps. So, oh, my laptop just restarted. So now what? I wanted to speak about implementation, and depending, I have a little time and don't have my laptop still booted up, so I think that I will not be able to do a demo, but I can tell you what you can find and things like that, and if you have some kind of spare 5 minutes, I hope that I will be able to show you. So what do we need? We need some kind of a middleware that is the central software for the TV. It integrates everything, the streamers, the data APIs, the set-top boxes, everything you need on one place. You need some kind of JavaScript knowledge. You need Google and Stack Overflow to help you when you get stuck, of course. And you need some kind of a set-top box device. Where will you put it? So sounds simple, right? Yeah. You must believe a programmer and not the one with the Windows. So by building a demo, I tried to that this will be very difficult. I'm on the 81%. So by building a demo, I was going to make some kind of a widget or a TV app where you will have 15 YouTube videos from Voxxed. You can play it, you can stop it, you can share it on a Facebook or a Twitter. For some reason, I deleted it yesterday from the test group, so there is no chance I can get it back until my laptop starts in. But I will do some kind of coding time. Yeah, I will do some kind of an intro. Here is a YouTube splash screen as you saw it earlier on a TV, and something about YouTube APIs. You have two kind of YouTube APIs. One is data API of version 3 and one is iframe API. The data API is used for you to get the information and the iframe API is used for you to output the video. Luckily both are available like JavaScript, and you can they have their own developers, and you can put it in the head corner of your web app, of your web page. And the API can be used without the login, as I use it right now. But Google supports device login, and you can do personalized information, subscriptions, and things like that if someone logs into their account. So this is some kind of a small talk about the keys. This is really hard to achieve without any kind of demo, but perhaps Rotla, is this laptop connected to the internet? No. Okay, so the keys. The keys are the first thing you need The keys are the first thing you need to implement your app. So you would need to make a new app on a console developers Google. I will get your link after it, and I think that I will later upload some kind of a code. Though it's some kind of proprietary code, I will upload it so you can see it, because I will owe you the live demo. So back to the topic. You need to create a new app on a Google's developers console, and when you create a new app, you will have some kind of sections where you will be able to get keys. You need client ID and a client secret keys that you put in your code, and this will enable you to use the data API. When everything is set up, you can use some kind of endpoints, and I will talk about those a little bit later, to grab anything from the YouTube videos, things like that, etc. So this is a very interesting and very famous picture. So APIs. I really am a big fan of programming from the scratch, and from using vanilla JavaScript, vanilla Java, and things like that. But sometimes we really need to use the APIs, and the Google for YouTube has a lot of them. The most important thing is that they are REST based with some kind of envelopers you use on JavaScript. So you have list, insert, update, or delete operations, and for some kind of endpoints, for example like search, you of course have only list. You cannot update the search. But for video you have all four of them, because you can update, insert, delete, and list videos. Usage also depends on whether user is logged in or not, and in these purposes we are using device login. The only thing you need when you're fetching keys is to enable OAuth and enable device login, and with some kind of code you will able to put it in your code. So I'm getting coding time. I'm getting perhaps a little bit boring, but I really apologize. We didn't expect these things that will come this way. So we will blame the Microsoft. Okay, the Facebook APIs. They are in the concept similar with the Google, but how many of you heard or used the Graph API, develop some kind of Facebook apps? So perhaps few of you knows what I'm talking about. Graph API is a little bit different. It's a REST based, and when someone tells me that it's not REST, I go mad, because it is a REST based, with the exception that you can say I want this, and this field, so give me answer only on this. So currently it's 2.7 version. It is very restrictive and needs to be approved by Facebook. The process is very simple. You need a complete Facebook account. You go to developer you go to developer section, create a new app, get keys and things like that. And when you get the keys, you go with you can implement them. You also get an ID and a secret API key that you will be using in a code. And when you do a Facebook OAuth login, the device login will also be present. So the funny thing and the interesting thing also is that this API is really restrictive, as I was talking about. You cannot see anything about your friends and that information. So you can use it to share data to the Facebook. You can use it to fetch data, pictures about yourself and things like that. So it isn't best scenario for a TV app comparing to the YouTube, for example, but it can be used on some level. So I think that my laptop has booted out and I have just 10 minutes. How much of these 10 minutes do I have before the prison? 5. Okay, do you want to see a quick view of live demo, or yeah, okay. So I hope this will go soon. Sorry. And the most funny thing is that the picture of my friend who has gone on his degree last week for some reason appeared on my desktop. And this looks like some kind of big update because everything is animated. Whatever. Hi, someone. We've updated your PC, I know. Okay, while he goes throughout the updating of PC process. Yeah, I hope this will really be soon right now. While it goes to the update of the TV process, I will speak something about Twitter APIs very fast. Twitter APIs are just REST endpoints, and you don't have any kind of a JavaScript developers already coming out from the Twitter. So you will need to use some kind of a proxy, or to use AJAX requests for each information you get. And of course, you can do something. You can use something that is already done. On the end of my presentation, you will have some kind of QR code where you will have a link to the GitHub, to the Jublos CodeBird. Sorry to the guys at Jublo, to the Jublos open source CodeBird APIs that envelop all of these REST functions and that you can use directly, inserted it in your head and use directly in your JavaScript code. And everything else is pretty much the basic. So that's about the Twitter APIs. And the one thing I also wanted to, that was intended to be my last part of presentation, is to speak just a little bit about the challenges and threats and problems you get when you are using these things. So yeah, I'm online. Thank you. And I hope he did. I need to go to my VPN first, because I need to connect to our servers in Banja Luka in order for you to see each part of this. Okay. Do we have? It's flashing. Okay. Do we have? This is the screen. Okay. As you can see, I really like vanilla JavaScript. Most of this is vanilla JavaScript with some kind of modules. Has anyone heard about modules framework? It's a JavaScript framework that enables you to do object-oriented programming in JavaScript. It's pretty basic without many stuff, high-tech geeky stuff that other guys were talking about. So this is an app skeleton. This is of course middleware specific. I will just, yeah, okay. We will define a widget, return it as an object. We will do some kind of init script. I think each one of you knows about this kind of code. This is something that puts a new script dynamically into your heads, into your head of the HTML. And we have two functions. One is initialize, and here we will load the CSS, do the init parameters, put the language and localization. And the second one is render. This will get triggered when you first time trigger the app. Init will trigger when you load the box, when you load the TV portal, and the render will trigger when you enter the TV box. But this is not so interesting because it's really middleware specific. So I will just put two screens here, and I will immediately switch to the YouTube demo. So going YouTube. Okay, we will need some things. I have some kind of a paper, and don't know where it is. Perhaps that isn't one. Okay, I will need, here it is. So just with the functions I put in this step. Okay, I wrote down some kind of init YouTube script and load G API or Google API. The init YouTube script will just put these two scripts. You can find everything on the end of the presentation. We just put these two scripts in head of HTML, and we'll put in global header your API keys. Of course, in real implementation you will do with these properties and things like that, but for the demo purposes I put it right here. So the second thing, and we will do a init YouTube from the init function when the portal loads, so we are sure that it will load when you start your TV. And the second one is loading of Google API. If you don't use YouTube app, you don't need Google API, so we will use it in the render function to trigger it first time we enter the YouTube. So when we are speaking about Google API, we just need this function GAPI client load. You will say that it is a YouTube, you will say that it is version 3, and we will do some kind of a callback when it's finished, and this is the search for Voxxed Belgrade items. And I will go to that implementation. It's on the end, and here is the real code you would need. So I have some kind of a query. It's Voxxed Belgrade, and I will form my request, and this is the request you will get no matter what with the middleware you're using, or no matter whatever you are using. You will have queue for the query. You will put your query there. You will say, I just want a snippet of this video, just basic information. You will say, search for only videos, don't search for playlists, subscriptions, and things like that, and give me the 15 results, because we will show the 15 results on TV. And of course, you will asynchronously execute that request. When you get the answer, you will get some response object that comes from a YouTube, and if that response object is valid, you can see this response, and response doesn't have an error. Error is basic HTML response code. You will do some kind of parsing of this data. So I will just speak about things that may be interesting to you. Sorry. Okay, so we have we will make a new JSON object with the title that we have from data snippet title, with description that we have from data snippet description. We will put thumbnail URLs. The best suggestion for you is to use the medium ones. We will get, of course, the video ID, because we need to play it if you want, and we will push it to some kind of list that works with this middleware. And of course, if there is some kind of a problem, we will say unable to fetch YouTube videos. When we get all of these done, we will reset the data source we have, and we will say YouTube result list is active as a container, and it can be accessed with the input device. Up there in the code, we have init of the YouTube player, so we got all the videos. We need some kind of player that will play back, and this is the second API I was talking about, YouTube iframe player. So we will put just one div tag in HTML and initialize it with the YouTube functions. We will say, okay, start it with this video, put it this height, put it this width, and some kind of player variables. Enable JS API, this will enable us to do play, pause, and things like that with JavaScript. Show info, don't show me the info, don't show me the controls, because I don't have a mouse as an input. Use HTML5, please, don't use anything else. Go to the Windows mode that is opaque, disable kilobytes, and is also the true, and I really can't remember what rel is, but of course you can browse it. And when I finish initializing my YouTube video for the first time, I will trigger something like show video when the customer press OK, and I will say if YouTube player is not defined, please initialize it. If it is, please queue the video by ID. This is also a YouTube player function. It's not our function, it's function that comes from the API that will load another video. When everything is loaded, I have two more functions. One is play video and the other one is stop video. And it also uses the basic YouTube iframe player API that you get from the Google. It uses their own functions. So I will hope I will be able to do a very just to say a little bit. Am I connected to my VPN? Sorry. Cancel. Okay, okay, we are on the internet, we are accessing right now. So this is an emulator for this screen. As you can see, it's very similar to the one you saw. I really am sorry about all the problems we had, but I'm really trying hard to get you as interesting as possible. So I will log into my middleware console, and I will do some kind of middleware specific job. I will say upload widgets. I will choose a file. It needs to be in a zip. And I will go to the second step, where I have already my YouTube implementation. Press open. Go to the next step. I will deploy it. And I will say it goes to the test widgets. And I will trigger it by a hotkey blue. Color key blue. Okay. Save. And when I reload my portal, in production purposes, there is some kind of a heartbeat mechanism, and the widget will propagate directly to the TV without the customer doing anything. And when I press the blue button, I should get the 15 videos. Yeah, some kind of applause for support, please. Okay, thank you. So this is the first part of the live code. It has only YouTube in it, no Facebook, no Twitter. You can go right or left. You would be able to. I cannot use this because this is some kind of a demo and it is on another server and it is really hard for me to play it on the box. But you can see most of it in emulator. For example, I will use this just one important thing. I cannot play live stream here. I can get it, and when I press play, which would be the play button, you will get something like this. This is the downside of these APIs. If you use YouTube iframe, every kind of a protection, for example, when you see the ugly message, please play it on a YouTube site, will also appear. This is embedded player, the one that is used on news portals and things like that. And when you are on a news portal and someone shared the YouTube video and you cannot play it, for example, on Facebook or any other site, you will go to the YouTube. The problem is you don't have a YouTube right here. You don't have a real YouTube site on set-top box. So this is a really big downside and something that you need to consider when you are thinking about implementing something like that. But if I choose some video that guys from the box didn't protect, this is a video from one of my colleagues from the last year, and you will see it starts playing as I played it on the TV last time. Okay, so I will press S as a stop button and press delete as a back button, and I will go back. So the second and the third part is making these YouTube videos be shareable on a Facebook and a Twitter, and this is really easy. So I have facey basic part of my code, and I will do first thing, I will put Facebook async in it. This is a callback that goes called from the Facebook JavaScript. When you insert the Facebook JavaScript, I will do it just underneath this part of the code. Sorry, here. So I have an init Facebook, and I will use this kind of URL to insert a script for Graph API. And I will get some kind of Facebook token from our settings, so I don't come in this demo authorization process and things like that, to make it a little bit more simple. And when this script is downloaded, when it's downloaded and when it starts executing, it will call back a window Facebook async init. So you must need to put it in a window namespace and to call it each time like that. And this will initialize a Facebook API. So you need some kind of API ID. Please don't use this. I'm just joking. They are demo IDs. You will say enable cookies, enable Facebook ML. You will not do that. You will say what is your version, and it will get everything ready and up for usage of Facebook API. So I did some kind of a code that will enable me to use it with a remote controller and things, but I will skip that right now. The important thing is the call at the end. So when I press some kind of remote control, I think blue key here, button, I will go trigger the share video on face function. So here it is everything you need as an example how Facebook uses their own API in the JavaScript code. So okay, I will do some kind of code to get an video ID of my YouTube video I want to share, and I will do just like this. Each and every Facebook API function call when you are using it, Graph API like this, has completely the same body and signature. First, you define an endpoint you would like to trigger, and you can find all the endpoints on the reference you will see at the end of this presentation. As I'm posting to the Facebook, I will use post HTTP. And I will define a callback function that will be triggered when everything is finished, the good or the bad way. And the thing that is also important is this access token I had used from my properties, and it is done by that device login we spoke about on the beginning of the presentation. And when I end this, the Facebook callback gets called, and if it's okay, as you can see, it will put some kind of notification video share to Facebook or video not share to Facebook. And very fast to do with the Twitter. With the Twitter, I'm using this Jublos Codebird proxy, and it has proxy also on our servers. The backend is in PHP, and and all the function, all the requests you are sending from your JavaScript using Ajax and the JavaScript APIs gets converted to PHP, solving cross-orient policy and things like that for those who know what I'm speaking about a little bit more, and it goes directly to the Twitter. So about the Twitter, I will just do this. I will init Twitter, and as you can see, we hosted it on our servers, this JavaScript, and I will do a load code bird, and I will do this also asynchronously when I start the app. I will set the proxy. I will set customer keys. The very important thing I forget about the Twitter is that you have two sets of keys. One is for the app and the others are for the customer, and if you want to use it, you need both sets of keys. That makes 4 keys. So these are these are the tokens I was talking about. Twitter token and Twitter token secret. That the first one is consumer key, and it is connected to your app. When you make a new app on a Twitter, you get those keys. And from the profile manager, I get Jovica Kesic credentials, Milos Galic credentials, specific credentials for your users. And if everything is okay, I will just call the callbird proxy, JavaScript, and set the tokens. And I'm good to go, as I was with the Facebook. So it's really easy, and you don't need a lot of time to get into it. And it can be useful on your sites also if you don't do TV apps. But if you want, call me. Okay, so when we want to share video on Twitter, we have exactly the same code. We put youtube.ba item video ID, and we just do the callback call. We need to say what endpoint are we calling. We are calling the status is update. We need some kind of a JSON that is payload for that request, and we say status, and the text is please check out this great video on YouTube, blah blah blah. And the third one is of course the callback. As you can see, each and every one of them is copying one from the other. The problem with the Twitter, it has a great APIs, it has a great compatibility, it's REST, you can do whatever you want with it, you can fetch any data you want, but the problem is it doesn't have the device login. So we need to do some kind of a workaround. That is one of our challenges. And since it has standard OAuth, I hope that most of you know what it is. You get some kind of a tokens, you go to their own page, you authorize the app and go back. We did some kind of a workaround to make it device login with our own code, as we had with the Facebook or YouTube. And that's it. So we can save this and go to the 4th iteration. I had this with these zip files with iterations, and I will delete the current app which isn't complete, which is just YouTube. I will say please search for VDB demo. I will say delete this one. I will say, of course, our middleware has some kind of mechanism that allows this to be done differently, but I'm right now on the VPN, so I need to do this like this. So this is the final code with the Twitter and Facebook search share also, and I will say deploy. I will say test widgets. Okay, select, and of course again color key blue, and I will finish, I think, really fast. So if I press the blue button now, I have the new ones. I think they are familiar with the ones I have here. So if I press the green button on my remote or on my emulator, I will share it to Twitter. And if I press the blue one, I will share it on the Facebook. So I will share the Matiax video on both. I will press blue. And of course, you would need to do some kind of perhaps more intuitive feedback to the customer, but this is just a demo, so I didn't bother with it. And the green will share to Twitter. And when I switch to TV app right now, where is my remote? Sorry, remote. Does anyone saw? Yeah, here it is. Okay, so if I enter these apps again, menu, and go to the Twitter, I should see his video shared here. Sorry, this is my home. I need my tweets. Something went wrong. Sorry. Green one. Twitter.com. I hope. For some reason it isn't here, but you can see it here. so I can play it, and I've shared it successfully to Twitter. There is some kind of cache here in the middle, so perhaps that is a problem. And this is my Facebook page, and of course I have it right here. Another downside, that if you share it like this without the standard share Facebook share input window, whatever you call it, it won't, how to say, syntax highlight the video, and it won't form it nicely, but it will work. And you can say, Matthias, Marichek, pardon, sorry, Marichek's video from the last year. Okay, that would be it. I will just do quick how many times I'm done. I'm really done. Okay, just to give you a link to the PowerPoint, sorry, to give you the link where you can find all of these informations. Okay, this is my presentation, and it has some kind of a backup. I had really nice pictures for you guys, so you can scan it with the QR code or enter this link to see slideshow from current slide. Okay, you can scan it, and every resource I was talking about will be on this, or you can just enter telegroup.video/vdbtalk. And the other important thing for those who okay, I will wait a minute, for those who were playing the game with us, is of course QR code for telegroup giveaway. You can see it, it's a widget. I think that everyone saw it, but it's a widget also here. This was the third one, and the fourth one will be shown, but this is the link on the resources page. Can you scan it? No. Lot of technical issues, so would be a little bit difficult. My presentation was probably too techy. This isn't so important for the prize, but you can the prize QR. Sorry. Okay, we just need a prize QR, and it's here. And from the current slide, sorry, and I can give you the link. It's telegroup.video/. It's working. Nećemo ovdje moći, morat ćemo to dole. Zato što počinje drugi čovjek za 10 minuta, 5-10 minuta. Did Miloš took any picture of me? Da se isključio fotoaparat. Tačno sam znao. Link je telegroup.video kroz P kroz ne taj, kroz Cassandra, ja mislim. Da. Ok. Da, svi koji hoće da dobiju ove nagrade jer su se mučili i slušali mene kako se snalazim na sve moguće načine. Everyone who want to see and get these rewards, we have 6 rewards for you guys, and those will be randomly chosen with our software. I hope this one will work. And if it's not, we will do this, and this. So someone will go. The people were living without the computers 20 years ago. So, thank you very much. I have Tom Hanks on the end to say the Hanks, the only perhaps joke you will be able to see. Thank you very much. I did my best in this situation. So, and sorry for the problems.
Good afternoon and welcome to this closing session. My name is Sasha and I'm here in behalf of Pioneer. I'm brand ambassador here in Serbia and I will talk a little bit about Pioneer solutions for empowering global commerce. So let's begin. A little bit Pioneer. Pioneer is young and fast-growing company, which specialty is cross-border payments, and it's mentioned for business use only. Personal transactions, as I want to send my grandmother some kind of money, it's going to be rejected. So please don't use it for that. Pioneer works today in more than 200 countries, more than 150 currencies, and today it has at least 3 million of users. That's quite impressive numbers, but mostly people use Pioneer services because it's quick, flexible, and it's trusted. Also, it's a one-stop shop. You can use Pioneer for a whole range of services for your business. So here we have Pioneer's offering. First one is how to be paid, and second one how to spend your earnings. On the left side, there are 4 ways to get money. You can get your money from freelance marketplaces. You can use billing service, global receiving accounts, and you can get paid by your Pioneer peers. Whole story about that I will be later. Also, your earnings. Money which you have on Pioneer account, you can choose local bank withdrawal, you can withdraw money from ATM, any ATM, and you can purchase online, in-store, and also you can pay your buddies, your freelancers or somebody with which you work. And this is a little short story about Pioneer in Serbia. Serbia is a small country and it's about 7 million people lives here, but in world of freelancers, it's a very big company. It's a very big country. Today we held around 10% of freelance market, so it's very significant. Also, in freelance market, on freelance and SMB market is targeting mostly by Pioneer. We have significant growth in last couple of years. Today, in this year, we have more than 3,000 new active users. So now it's about 8 to 9,000 of users in Serbia. And also here are some numbers. There is a high raise of some services. Billing service is near 200% more used than in 2015. Make payment service plus 100% and global payment service. In this year, whole amount of money is $36 million. So it's much money for such small country. And now what we have new here. new service for Serbia is withdraw to bank account. That was announced in June of this year. Also, billing service and make a payment services are with new features, and some short description you can find on this slide. So if you want to receive some money, some funds from clients worldwide, you can go with free services. Basically, it's two types of services. One is mass payout from mass payout partners, and one is for working directly with clients. It's global collection accounts and billing services. For marketplaces, you have lots of marketplaces. Maybe you know Upwork, Freelance, 99 Designs, and they have a direct contract with Pioneer. So if this way is very secure. You make contract via marketplace. They take their fee, but you are secure for receiving money if your job is done well. When they approve money, you get your money on Pioneer account very quickly. If you work directly with clients, you can use two services. One is global payment service, and one is billing service. For mass payout companies, there is more than 2,000 companies today active contracts with Pioneer, and I talk about it. It's like Upwork, Freelancer, whatever you like. Also, there is high rise in real estate via Airbnb. Maybe you are used for that services. For working directly with clients, there are a lot of challenge. First challenge for working from Serbia is how can you be sure to be paid, and that's the real complex thing. So don't go with bad contracts and with people on which you are not sure to deal. But for getting money, there we can help. We can. There is two ways. One is global payment service. On global payment service, you get a virtual bank account in some of global markets. We have in USD, Euro, and GBP. So if you want to work in United States, you get a virtual bank account, and company on which you are doing some kind of job can directly pay to that account to your Pioneer account. With this system, we can avoid traditional problem with complexity, cost, and late payments. Too many times people get stuck with their money. It's held somewhere without any visible reason, and nobody can solve that problem. Also, for this global payment service, it's pretty cheap. Fees are up to 1%. In the Eurozone, it's free of charge. At States, it's 1%. For billing service, that whole package of services with that great biggest advantage is flexibility. You just fill some fields when you have I assume you have a Pioneer account. You have just to log into Pioneer account. You click request a payment. Then you have a couple of fields. You fill which amount, and this is very important. Payments for business use is approved. For personal use is not approved. So you cannot use it for that sending money to some relation or so. And when you fill out the details, you just click send, and everything else is done by Pioneer. They will send instructions to clients' email, and which is when it has to be paid and everything else. Also, there is new features. You can send this payment request in advance. You can track these payments. You can schedule reminders, and this reminders for payment is quite amazing. When you want to bother your client, it's not so polite, but this bothering client for please pay this this bill is sent by Pioneer, not by you. So you are actually, you just make some clicks. I want to remind my partner, my business partner, and Pioneer takes care of it. Also, soon there will be to attach invoices, to create automatic reminders, and APIs are just in way. So if you have some company which is within invoicing system, or you have some invoicing system, and you can integrate with Pioneer. Here are a couple of benefits of billing services. It's security, lower fees, faster payment, and this flexibility. Flexibility is given, by the way, you have with these services your virtual POS terminal. So you can be paid through any credit card, Visa, MasterCard, or something like that. So you can sold your bike in US, and they can pay with their credit card. Also, there is e-check. We are not used for that kind of service, but in America, it's pretty common. Here is a comparison chart, and with this we can see how we can be paid. Is that service is for companies or for individuals? Also, there is fees. It's highest fee is 3%, and it's for credit card payment. Yes, individual can pay, but only for business use.
So in other words, in order to receive money, you have to be at least a freelance in the company.
No, you just need to have some kind of contract or some kind of business relation. Me and you can have contract. I hire you for some kind of work, and I send you invoice. You get invoice, and you can pay me via credit card.
And we don't have to be members of.
Not for this type of service. Not if we are both members of Pioneer, we can use another service. And in that case, fees. No fee. No fee at all. It's free of charge. So, if somebody has any question, please let me know. And that's for receiving money. For withdrawal, there are a couple of ways. So you have money on your Pioneer bank account, and you want to spend or withdraw. New service for Serbia is withdrawal to local bank. You have a couple clicks to have and to be approved, and then for any further withdrawing, it's just like automatically. You can use Pioneer prepaid MasterCard. With prepaid MasterCard, you can spend all your earnings anyway in store or online, or you can draw cash from any ATM which supported MasterCard. And also, that was the question, you can use the make payment service, you or your buddy. It's just a way in-house transfer, and that in-house transfer is free of charge. So I a little bit shortened this question. If somebody has some questions.
Okay, so can you hear? Yeah. My question might be slightly provocative, but since your talk was short, we've got time. How did you solve the legal problems that seem to be persistent to Serbia alone? And I'm mostly asking you, why is PayPal having problems still allowing for payments between two businessmen in Serbia, and how did you solve that?
I understand the question, and we were working a lot about, and we had with national, with government, we had conversations and approval. Pioneer is held with e-money license for Europe, and the main service for Pioneer is cross-border payment. So we don't, our services are not mentioned for payment in Serbia, but for incoming money for within Serbia.
So, in other words, if you and I, being the citizens of Serbia, make a contract and have accounts on Pioneer,
Yes.
can we transfer money between each other, or is it illegal?
If that money is not in Serbia, so for you have income from some other source, then it's not illegal. If you have income from US and you want to transfer to another way, it's not into Serbia.
But I was specifically asking, so if you and I have a contract, we both live in Serbia, we both have companies in Serbia.
It's not mentioned to be used for that kind of service.
Okay, clear.
So it's not mentioned for that, but for that international transfers, it's mentioned to be used.
Thank you.
Thank you.
I have a question about getting money from the ATM.
Yes.
For example, a lot of times different ATMs giving different rates. Do you have any kind of the best way to avoid the rates? Because when you go to the ATM and you can withdraw all money, you have two options. First one is to have the guaranteed rate, and another one is to have a non-guaranteed rate. When you choose non-guaranteed rate, you get more money. I mean, you spend the less US dollars to get the
so no, rate is not an issue. Rate is from MasterCard. You have fixed fee for withdrawing money. So if you in total, if you have a cash out for, I don't know, $100, you have fixed rate for free and 315. You will be charged for 103. But if you push out from ATM $600, you will have the same fixed fee, and within that you have that currency change. Also, currency change is fixed by MasterCard, not by Pioneer, and you can check it online.
But when I get
for that guaranteed conversion and that non-guaranteed conversion, if you use guaranteed conversion, then you use that local bank currency exchange rate, and if you use non-guaranteed, then you use MasterCard.
Oh, well, that's the point. I mean, I didn't know the difference, but I saw that when I use the non-guaranteed,
yes,
they charge me less.
Yes, you have.
So the MasterCard,
it's better.
It's better.
It's better. It's way better.
Okay, I understand. And I wanted to ask one more thing. What's the fee for any use on the ATM?
It's fixed, 315.
Okay.
USD.
Thank you.
What's the procedure of getting MasterCard from Pioneer?
You just sign with link. I can send you a link. You have also refer a friend loyalty program, and if somebody is a current user of MasterCard of Pioneer services, he can send you a link to be signed, and when you get payment from some marketplace you bought, will get $25 back.
Thank you.
Anybody else? So if you want to get in touch with me, here's my email, and I can answer or try to answer or try to find for any question you ask, which is by Pioneer and its services. And that's it. Thank you very much.